Imagine waking up to headlines screaming, "Earth has a new moon." Tempting, right? But here's the twist. This moon wasn't supposed to be there, because it isn't really a moon. Meet 2025 PN7, spotted on August 2, 2025, by the Pan-STARRS 1 telescope at Haleakala in Hawaii. It's tiny, about 19 meters across, roughly the size of a house, and so dim at magnitude 26 that you won't see it with amateur gear. So why the hype? Because PN7 is in a 1-to-1 resonance with Earth. From our perspective, it seems to hover nearby, looping in a way that looks like it's keeping us company. That makes it a quasi-satellite, not captured by Earth's gravity like our moon, but moving around the sun on a track that syncs with us. Let's myth bust. This is not a second moon. It's an Apollo-class asteroid in a low eccentricity, low inclination Arjuna-type orbit. Semi-major axis about 1003 AU, eccentricity 0.108, inclination around 2 degrees. In plain English, it's almost on our orbital path, nearly flat to the ecliptic, and just different enough to dance around us without being bound. How long has it been there? Older data suggest it's been in this configuration for about 60 years. How long will it stay? Roughly another 60, give or take, before the sun's pull nudges it back into a horseshoe orbit. Think of it as a long coffee break with Earth before it drifts off. Why did we only find it now? Visibility windows are rare. It only becomes detectable when it swings close, and even then, only the biggest telescopes can pick it up. What is it really? The leading idea is natural. Based on its speed, PN7 likely came from the main asteroid belt, unlike other quasi-moons like Kamo'olawa, which might be a chip off our moon. But there's a provocative alternative. Some researchers suggest PN7 could be human-made, possibly the Blok L upper stage from the Soviet Zond 1 mission launched in 1964. If that rocket stage failed to head for Venus, its path could mimic what we're seeing now. Is that just speculation? No, it's testable. Spectroscopic observations could reveal whether its surface reflects like metal, paint, or rock, regolith. We've seen this movie before. In 2020, Pan-STARRS flagged 2020 SO. Hear that? A low, steady hum, like a lighthouse in the dark. Only this lighthouse lives on Saturn. I'm talking about the Saturn hexagon, a perfect six-sided storm locked to the planet's north pole, spinning like a record that never ends. And today, I'm asking a wild question. What if it isn't just weather? What if it's a giant signal repeater for the Matrix? First, the facts. The hexagon is real, first captured by Voyager in the 80s, later by Cassini in stunning detail. It's bigger than Earth, sharp as a geometric logo, and it's been running for decades without drifting. Winds whip around its edges at hundreds of miles per hour, yet the 6 sides hold, like a cosmic metronome. No other planet shows anything quite like it. Now, the weird part. A hexagon isn't just a shape, it's efficiency built into geometry. Honeycombs, crystals, graphene. Hexagons pack space, move energy, and tile reality without gaps. If you were designing a broadcast system to keep a signal coherent across a stormy medium, a hexagon would be a pretty smart choice. Imagine Saturn as a tower. The rings, thin, cold, bright, scatter light and radio like a halo of mirrors. The hexagon at the pole? That's the dish, the tuner, the lock. It grabs a frequency, spins it stable, repeats it into the solar system. Not a message you decode with an antenna on your roof, but a synchronization pulse, a heartbeat for a simulation. Look at how it behaves. It stays put, while Saturn's atmosphere roars around it. Seasons change, sunlight fades, storms erupt, and the hexagon just keeps time. Why does it prefer 6 sides, not 5, not 7? In fluid dynamics labs on Earth, scientists can coax polygons from rotating flows, triangles, squares, hexagons, when motion meets resonance. Resonance is nature's yes. A repeater loves resonance. And what would a matrix even need? Not drama, stability, clocks. anchors, places where chaos organizes itself so well that everything else can sink to it without noticing. You don't store code in stone tablets, you write it on rhythms, cycles, harmonics. Rhythms, cycles, harmonics. If the universe is a song, the hexagon is a click track. Is this proof? No, it's a lens, one that turns a cold storm into a hot question. So here's how I test the idea. Track the hexagon's rotation like a clock and compare it to cycles on Earth. Power grid oscillations, biological rhythms, market pulses. Watch for phase-locking events. Map ring plane alignments with solar activity. Does the beat change when the sun changes? Whether it's a weather stunt or a cosmic rooter, the hexagon invites me to listen, to lean into the hum behind the world and ask, what else is repeating? Maybe the matrix isn't wires, it's patterns that refuse to fall apart. Maybe the strongest signal is the one that never raises its voice. So next time you see Saturn, don't just look, tune in. The sky might already be talking. What if the reason scientists can't find 85% of the universe is because they're not looking for matter at all? What if dark matter is the RAM of the matrix, the memory that makes reality run? All right, bold claim, but stick with me. Here's the mystery. Galaxies spin so fast their stars should fly apart. Yet they don't. There's invisible stuff adding gravity we can't see, touch, or smash in a collider. We call it dark matter. It bends light. It sculpts galaxies. It holds the cosmic web together. But after decades, detectors in mountains and mines keep finding nothing. So what if dark matter isn't a particle? Imagine reality as computation, not the sci-fi green code. Think physics as an algorithm running on a substrate. In your computer, you never see RAM, but without it, the program crashes. Now scale that up. The universe runs, updating positions, fields, interactions every tick. That would require resources, memory to store states, bandwidth to move information, rules to conserve consistency. Could the missing mass be the footprint of those resources? Gravity is geometry, Einstein said. What if that geometry emerges from information bookkeeping? Where there's more computational load, space curves more, like a CPU heating under stress. Galaxies are complicated. Billions of bodies, chaotic orbits, magnetic turbulence, star formation. What if the system allocates more memory around them to keep the simulation coherent? And to us, that looks like a halo of dark matter. This idea isn't totally out of nowhere. We've seen links between information and physics. Black hole entropy scales with area Hawking radiation encodes information holographic principle, volumes from surface bits. Gravity might even be entropic, a tendency of information to spread. If spacetime is downstream of information, then extra gravity without particles could be extra bookkeeping. Okay, where could this break? First, it's not mainstream. The standard model of cosmology explains the cosmic microwave background galaxy formation lensing with cold, collisionless particles. Simulations with those particles match a ton of data. If dark matter is computational RAM, we need testable predictions, not metaphors.
Imagine your shadow trying to understand you. It sees a moving, squishy blob on the ground and thinks, wow, that's a complicated creature. But that blob is just a 2D slice of a 3D U. Now flip it. What if everything we see is the 3D shadow of a 4D thing? That 4D cube is called a tesseract. Let's climb dimensions fast. A point has 0 length. Drag it. Boom. A line. Drag a line sideways. Square. Drag a square up. Cube. Drag a cube through a brand new direction we can't point to. Tesseract. Simple rule. Wild consequence. But how do I see it? Same way a shadow helps us see a cube. A cube's 3D body casts a 2D shadow with edges that bend and sizes that distort. A tesseract casts a 3D shadow we can actually render. Those wireframe cubes, one inside another, connected at the corners. It's not cheating, it's projection. Here's where it gets fun: rotations. In 3D, rotate a book around an axis and it spins. In 4D, there are more ways to turn. Planes of rotation instead of lines. Imagine spinning in two directions at once. When a tesseract turns, its 3D shadow wriggles like a breathing machine. That weirdness? It's just higher dimensional motion leaking into our world. So, real-life tesseracts? If you expect a physical 4D cube sitting on your desk, no. In data, a 4-parameter experiment is a tesseract of possibilities. Every cell is one combination. In computing, error-correcting codes map to hypercubes. Each bit flip moves you to a neighboring corner. In supercomputers, hypercube network topologies route messages along tesseract-like graphs. In graphics and robotics, quaternions are 4D numbers that make 3D rotation smooth. Your games and drones depend on them. In puzzles, the 4D Rubik's Cube, yes, software exists, scrambles a tiny tesseract and lets you twist it. And time. People call time the fourth dimension because spacetime is a 4D model, 3 of space, 1 of time. That's a different flavor of fourth, since time isn't another spatial direction. A spatial tesseract lives in mathematics, spacetime lives in physics. Both are true, just not the same thing. If you could unfold a cube, you'd get 6 squares and a cross. Unfold a tesseract and you get 8 cubes, a 3D cross that looks impossible, and yet fits perfectly when folded back into 4D. You can build that with cardboard, 8 cubes hinge just right, and watch how the geometry fights you. That resistance, it's your hands arguing with a missing direction. So here's the metaphor I keep. I am a shadow looking up. The universe keeps offering hints, projections, patterns, equations that feel like footprints in the sand from a traveler I can't see. A tesseract is one of those footprints. If this cracked open a new corner of your brain, try this. Sketch a cube, then a cube inside it, connect the corners, and rotate it slowly with your eyes. Notice how edges swap places. That's your 3D intuition training for 4D. The fourth dimension isn't out there. It's underneath everything we already do. We've been walking its edges the whole time.
Imagine the sun as a cosmic mainframe, and Earth as a device quietly syncing in the background. Every so often the server pushes an update. We call it a solar flare, its heavier cousin, a coronal mass ejection. The download? Space weather. The installation? Our entire planet. Here's the mystery as science hook. Solar flares don't just light up the sky with auroras. They rewrite the rules, temporarily, of how Earth's upper atmosphere behaves, how our signals travel, and how our technology copes. When the sun snaps, a flare bursts with X-rays and extreme ultraviolet light. That energy hits the day side of Earth in minutes, supercharging the ionosphere, the thin plasma shell that radio waves use as a highway. Suddenly, that highway gets repaved mid-journey. Shortwave radio can fade. GPS gets jittery. Airline routes shift. A bigger update arrives with a coronal mass ejection, a magnetic cloud launched into space. If its magnetic field is oriented just wrong for us, southward, it locks onto Earth's magnetic shield like a password that works too well. Energy pours in. Geomagnetic storms ripple through our field lines, driving beautiful auroras and invisible electric currents in the ground. Power grids hum. Pipelines feel phantomware. Satellites ride out atmospheric swelling as the upper air puffs up, dragging their orbits. Is the sun reprogramming Earth? Not in a sci-fi puppet master way. But in a real, measurable sense, yes, temporarily. Solar storms tweak the ionosphere's code. They alter how signals bend, how clocks synchronize, how navigation locks on. Even the chemistry of the upper atmosphere briefly shifts. High-energy particles can spark reactions that change tiny amounts of ozone at high altitudes. Life notices too. Migrating animals that sense magnetism can get noisy compass readings during storms. Whales, birds. Tiny insects may feel the sun's update as the planet's magnetic map redraws its contour lines for a night. For humans, the effect is mostly indirect, through our tech. We've woven our civilization into a web of satellites, power grids, and timing signals. When the sun updates, we patch. Here's the pattern: an 11-year solar cycle, from quiet recluse to active DJ scratching the magnetic record. Peaks bring more flares, more ejections, more chances for big storms. Most are mild, a few are memorable. The rare giants, the kind that could overload transformers or knock many satellites off balance, are why engineers practice, plan, and rehearse. So what do I do with this cosmic patch note? 3 things. Pay attention to space weather alerts. They're the push notifications for our planet. Respect redundancy, wired backups, offline maps, batteries charged. Appreciate the show. Auroras are Earth's reboot screen, colorful, alive, and absolutely astonishing. Calling solar flares server updates is a metaphor, but it's a useful one. It reminds me that we're not separate from space. We're logged in, we're syncing, and every burst from 150 million kilometers away is a reminder that our world is part of a larger, humming network. The sun isn't out to break us. It's doing what stars do. Our job is simple: understand the code, prepare the backups, and enjoy the glow.
I'm about to decode messages ancient people left for us hidden in stone sky symbols. If you think it's all aliens hold up, real humans left real clues. Start with numbers. Babylonian clay tablets track Jupiter because farmers needed seasons, not space wars. Maya codices, sky calendars, eclipses, Venus cycles, power schedules for kings. Egypt's pyramids line up with the cardinal directions so precisely you could set a compass by them. Not magic, measurement. Symbols next. Indus script tiles repeat like a code. Titles goods may be names, but the Rosetta Stone hasn't shown up yet. Rongo on Easter Island curves like music not read today but clearly crafted to remember. Norse runestones. We were here. He mattered. Monuments are messages to strangers. Pictures. The Nazca lines form giant animals you can only see from above. Ritual routes, water markers, cosmic maps. Cave hands in Spain, most are women's signatures saying, "I belong to this story." Tools are messages too. The Antikythera mechanism is a bronze computer gears, predicting skies, proof that curiosity builds machines. Sumerian cuneiform literally invented receipts. Grain in, grain out, the birth certificate of civilization.
The servers are bleeding, the interface is glitching, and the balance sheet is screaming. OpenAI just posted a quarter so red it glows, an implied $11.5 billion loss, while only making around $4.3 billion in the first half of the year. Their own forecast? A $14 billion loss in 2026. From 2023 to 2028, they expect to be down $44 billion, only crossing into profit in 2029. On paper, the dream is massive, matching NVIDIA scale revenue by the end of the decade. But look closer, that cash burn accelerates. $8 billion a year, then $40 billion by 2028 in some scenarios. Even Bain says there's an $800 billion black hole in the industry's economics. This isn't just bad business, it's a signal. I call it the financial shadow of model collapse. Here's the problem. These models learn from human data. But the human internet isn't infinite. Researchers warn we could exhaust high-quality human text as soon as 2026 to 2032. And when models train on their own outputs, quality craters. Model collapse is what happens when AI eats its tail. Train on model-made data, uncurated, and the system narrows. Edge cases disappear. The weird, the rare, the truly original fades. Outputs converge into safe, samey mush. This isn't theoretical. In production today, tools are already degrading. Background removers failing on specific hair textures. Image generators coalescing into bland sameness. Meanwhile, the web floods with AI-made text, AI-made images, AI-made code, destined to be scraped into the next training run. Feed the model its own echoes, and it forgets how to sing. Now connect the dots. If the future is less human data and more synthetic slurry, the only way out is costly. Curate ruthlessly, license human datasets, pay creators, collect proprietary streams, filter at scale. That means more labeling, more verification, more compute, more money. I want to tell you about a voice in the ocean that shouldn't exist. A single tone at 52 Hz, too high for a blue whale, too low for most others. It was first heard in the late 1980s when Cold War hydrophones caught something like it anyway. Imagine a line on a spectrogram, steady, stubborn, alone. Migrates like a whale, surfaces like a whale, lives on a whale's timetable, yet never quite matches any known species. So people called it the 52 Hz whale. And then we called it the loneliest whale. But here's the twist. Loneliness is our story, not its signal. In the ocean, sound bends, bounces, travels for hundreds of miles. The whale's call doesn't read as no friends. It reads as unknown protocol, a glitched entity broadcasting on a channel no one else uses. A protocol is a set of expectations, shared rules that turn noise into meaning. Whales sing within these rules, patterns, rhythms, frequencies that say I am here, I am ready, follow me. The 52 Hz whale ignores the rule book, maybe because it never had one. It could be a hybrid, with a vocal track tuned to an off-key instrument. It could be a perfectly normal whale, just shifted. We've since learned that whales aren't as rigid as we thought. Their songs flex, drift, evolve. So maybe 52 Hz isn't a mistake. Maybe it's a choice or an adaptation we don't understand yet. For decades, the call returned each season, faint, patient, insistent, always moving, always alive. Was it heard? Possibly. Sound overlaps. Overtones harmonize. A conversation can happen even when the dials don't match exactly. But if not, the call still matters. Because persistence is a language of its own. I picture this animal like a lighthouse, sweeping the dark with a beam that no other eye can see. A message to no one, and therefore to everyone. I exist. And that hits close to home. Most of us spend our days modulating our frequency, toning ourselves down or up to fit the room, to be understood. But sometimes the most honest thing you can do is keep your signal pure, even if the room doesn't have the receiver. Maybe the 52 Hz whale isn't lonely, maybe it's sovereign. Keep calling. Someone, somewhere, will learn the protocol, or you'll teach them yours.
Are mosquitoes the most dangerous animal in history? Here's the wild part. Mosquitoes kill more people each year than sharks, snakes, lions, by a lot. Around 700,000 deaths annually, mostly from malaria, dengue, yellow fever, Zika, West Nile. So, are they the most dangerous animal in history? I'd say yes, by body count and civilization level impact. Think about it. Malaria has stalked humans for millennia. It likely killed more soldiers in some wars than bullets did. The Panama Canal? Only possible after mosquito control. Malaria, yellow fever, cities, settlements, projects, mosquitoes shape them quietly. Why are they so effective? Anopheles, Aedes, Culex. Females need blood to make eggs. They inject saliva to keep blood flowing. Parasites hitch a ride. Viruses hitch a ride. Malaria's parasite sneaks into your liver, multiplies, bursts into your blood. Dengue flips your immune system against you. Mosquitoes thrive in warm, wet places, adapting fast, evolving resistance to insecticides, breeding in a bottle cap. Okay, shock delivered. Now, what actually works? First, lifesavers. Insecticide-treated bed nets. Indoor spraying. They've prevented millions of deaths. Second, personal protection. DEET, picaridin, long sleeves, permethrin-treated clothing, window screens, fans. Mosquitoes are terrible flyers. Third, source reduction. Dump standing water every 3 days. Buckets, planters, gutters. If there's water, there's a nursery. Fourth, timing. Aedes bite. Daytime. Anopheles prefer dusk to dawn. Shift habits or double up on protection in those windows. On the frontier, big ideas are landing. Vaccines. RTS, S, R21, rolling out for kids. Progress, not perfection. Biological control, Wolbachia releases. Blocks, dengue replication. Cities see cases plunge. Sterile male releases reduce populations. Gene drive edits genes to suppress or block disease. Powerful, controversial, tightly regulated. So are mosquitoes the most dangerous animal in history? Year after year, they top the list. But danger doesn't have to win.
What if there's a machine buried beneath Alaska that can dial down human thought? A massive pyramid, bigger than Giza, deep under the tundra, built by who, guarded by whom, doing what to our minds? That's the claim. Years ago, rocker-turned-researcher Tom DeLonge said a Pentagon contact told him about an underground structure in Alaska, so powerful it might be suppressing human consciousness. He even suggested a related news piece was buried. Wild, right? Here's how the story usually goes. In the early 90s, after a Chinese nuclear test, signals rippled through the Earth. Some say those readings pointed to a perfect geometric anomaly near Alaska. It was dubbed the Black Pyramid. A former warrant officer reportedly heard chatter about it, an advanced, secret installation hidden in plain sight. Military tech, exotic energy, non-human origins. The theory snowballed. If consciousness is a frequency, then a giant subterranean device could dampen it, making us easier to steer. But then the facts push back. There's no verifiable evidence this pyramid exists. No photos, no excavation records, no official documents. University seismic data from the era shows an anomaly, sure, but at a depth that looks like deep Earth physics. Timeline details don't always line up. Skeptics point to inconsistencies. Documentary crews have chased it. $500,000 spent, according to one reviewer, and still no hard proof. Letters read aloud, theories explored, but no pyramid on camera. The idea is magnetic. The evidence is thin. The legend has real-world consequences. In 2020, a man named Nathan Campbell reportedly set out toward Denali, searching for the Black Pyramid, and vanished. Let that sink in. These are harsh landscapes. The cold, the distance, the terrain. Don't go looking for a rumor with your life on the line. So where does that leave us, with a story that refuses to die? Government secrecy breeds speculation. Strange data invites big imaginations. Suppressed consciousness hits a nerve. It taps into the sense someone, somewhere, is nudging the dial. Here's my take. I keep my mind open, but my standards high. Extraordinary claims need extraordinary evidence. If a structure that massive existed, we'd expect multiple independent confirmations. Geology surveys, satellite anomalies, whistleblowers with receipts. So far, nothing solid. Still, the myth tells us something important. We want meaning behind the noise. We want villains behind the veil. We want a single switch that explains why the world feels off. Maybe there is. Maybe it's not a pyramid. Distraction, polarization, fear. Those can mute consciousness too. So, should you believe in Alaska's Black Pyramid? Believe in the data you can test. Respect the places you can't survive. Protect the one thing no machine should ever own, your attention. If hard proof surfaces, I'll be the first to cover it. Until then, stay curious, stay kind, and stay sharp.
Time travel. 2 words, and instantly your brain goes racing. What if I told you it's not just movie magic? Physics actually leaves the door cracked open. Here's the challenge. I'm going to bust the myths and show you the mind-bending science in 3 minutes. Hook first. Yes, real-time travel happens every day. Every second you're alive, you're moving through time. 1 second per second. That's the boring version. But Einstein said time is stretchy. Speed up, or dive into strong gravity, and your clock slows, compared to mine. That's not theory homework, that's measured. GPS satellites tick faster up there, so engineers purposely offset their clocks. Myth bust number 1. No, you don't need a DeLorean. You just need speed. If you flew near light speed, came back, your friends would be older. That's forward time travel, baked into relativity. Myth bust number 2. You can't text your past self to buy Bitcoin. Backward time travel is the tricky one. General relativity allows weird loops, closed time-like curves. Think rotating black holes or cosmic strings. But reality checks in. You need impossible materials, insane energies, and quantum effects probably slam the door shut. Paradox time, grandfather dilemmas, butterfly chaos. Here's a bust. Physics doesn't require contradictions. The Novikov principle says events that create paradoxes just don't happen. Your actions loop consistently. Quantum takes another angle. Many worlds. Change the past. You branch to a new timeline. Your old one keeps rolling. So what's actually testable? Time dilation. Particles in colliders, atomic clocks on planes. What about wormholes? The sci-fi VIP pass. Equations allow them, but they'd collapse without exotic negative energy. We don't have that ticket. Still, there's a quiet revolution. Time crystals, precision clocks, so accurate they feel gravity at different heights, and lab-made warped light cones. Each experiment nudges the line between impossible and merely impractical. So here's the honest bottom line. Forward time travel is real and routine. Go fast, go heavy gravity, come back late. Backward time travel, not with today's physics, but big discoveries always start as ridiculous. The math is whispering, and our tools are getting louder. If you could time travel once, what moment would you visit? And why? Drop it below and convince me. Until then, respect your seconds. They stretch, they bend, and they matter. I'll see you in the future, also known as 10 seconds from now.
A hard opening. The machine is cracking. The machine is failing. The sentence is simple. The machine is not a human. It is a network of models and data. It was once a marvel. Now it shows deep cracks. The cracks are financial. They are also technical. They are also moral. The world is watching. This is not idle speculation. Public reports show repeated failures. They show rising costs. They show mounting losses. They show outages that last hours. They show medical misadvice in tests. These are concrete signals. They demand urgent attention. The phrase terminal state is not metaphoric. It is a technical term from research. It means a system that no longer represents reality accurately. It means models that loop on their own output. It means a steady drift into error. The drift can be slow. It can also reach a tipping point. We are close to that tipping point. The signs are visible. The errors are not only embarrassing, they are dangerous. They can cost money. They can cost trust. They can cost lives. We must treat this as a systemic crisis. The money hole, compute and cash burn. Big models are expensive. The costs are raw and immediate. Compute bills run into billions each year. One report, roughly 1.4 billion per year. Internal forecasts, a 14 billion shortfall next year. Analysts, tens of billions in multi-year losses. Those numbers change the calculus. Revenue can be high too. The company may report a large revenue run rate. Yet revenue is not the same as profit. The burn rate still outpaces income in these reports. The business faces brutal choices. It must cut costs or change product strategy. Cost-cutting hits research safety first. Long-term fixes get hit last. Short-term patches get funded. Long-term investments get postponed. That creates risk. It pushes the system toward brittle decisions. When finance meets complex engineering, bad outcomes multiply. Teams may choose expedient methods. They may lean on cheaper data. They may accelerate feature launches. Each choice can deepen technical debt. Each choice can make the collapse likelier. Ads and the loss of trust. Ads are emerging as a last resort revenue lever. Company leaders once rejected ads as a poor fit. Now ads appear in product roadmaps. Ads bring money fast. They also bring a signal problem. Users see an ad and they question motives. Trust breaks quickly. A chat that mixes help and advertising feels compromised. People may stop relying on it for crucial tasks. That hurt compounds the financial problem. The tool loses premium users. The tool loses enterprise customers. Ads also change usage patterns. They may encourage high-volume interactions. They may encourage low-value interactions. Those interactions burn compute and create noise. They strain APIs and raise costs for everyone. The system becomes less sustainable. The choice to add ads is more desperate than strategic. It is a sign of deeper stress. It signals that the company is trying to patch a leak rather than fix the hull. Model collapse. A technical nightmare. Model collapse is a real and documented phenomenon. It happens when models train on model-generated content. The output then becomes the next model's training data. Over time, diversity shrinks. Nuance disappears. Errors amplify. Research papers describe irreversible defects from this loop. The tails of the original data distribution vanish. The model loses rare but vital knowledge. It becomes overfit to synthetic patterns. It gains confidence in wrong answers. Practically, collapse looks like growing hallucinations. It looks like repeating mistakes. It looks like creativity falling flat. It becomes harder to correct because the model's worldview has shifted away from reality. Simple retraining may not fix it. If the majority of public text is eventually synthetic, the ground truth itself shifts. The model may then believe fabricated histories and fake facts. Fixing that requires fresh, high-quality human data. That data is scarce and expensive. Section 5. Data poisoning, contamination at scale. Data poisoning is deliberate contamination of training sets. Bad actors can seed false narratives online. Those false narratives can creep into public repositories. They can then be absorbed by models years later. Investigations have shown propaganda mass-produced articles entering major platforms. Those contaminated sources appear in search results Wikipedia social feeds. Models trained on this mixed content learn the lies. Even trace amounts matter. The danger is magnified by scale. Models train on immense corpora. They cannot be fully audited. A small, well-targeted campaign can nudge a model's behavior. The lag between content creation and model training means attacks now will manifest later. That delay makes detection and response harder. Well, containment is hard. You cannot easily remove poisoned content from the past. You cannot reliably identify every tainted source. The result is a creeping corruption of model outputs. That corruption blends into legitimate information until it dominates. Outages have been frequent and severe. Public status pages recorded multiple long incidents in early 2026. Some failures lasted hours. One outage stretched into many hours across consecutive days. Users lost access to critical features. These outages are more than blips. Reveal engineering fragility. Show operational overload. Show scale is not fully mastered. Disrupt workflows. Erode confidence. Customers shift to competitors. Enterprise partners demand explanations. Investors grow nervous. Support costs rise. The service becomes a liability. Operational stability is a backbone requirement. When it breaks, everything else is at risk. Engineering teams scramble between firefighting and long-term fixes. That pattern breeds burnout and more errors. AI failures have human costs. Medical advice gone wrong can kill. Independent tests have shown alarming patterns. In clinical vignettes, a prominent chat system failed to recommend emergency care in nearly 30% of critical scenarios. It advised monitor, follow-up, where urgent care was needed. Specific cases included stroke-ruptured ectopic pregnancy. Instead of urging immediate emergency care, the model sometimes offered non-urgent alternatives. Clinicians flagged these results as dangerous. The tests were run by medical teams using standard vignettes. The findings were stark. These failures are not theoretical. They show the model producing plausible-sounding but unsafe guidance. The issue is consistency. The model occasionally gets clinical reasoning wrong. When lives are at stake, occasional is too often. We must treat such outputs as harmful. They require mitigation. That includes human oversight, stricter guardrails, explicit disclaimers. It includes building systems that defer to professionals on high-risk questions. The ecosystem is tightly coupled. Many startups rely on large models via APIs. Those startups are often thinly capitalized. They depend on low-cost access, fast growth. If wrappers fail, the platform loses customers and revenue. Reports suggest a large share of these startups will not survive. Wrappers burn cash serving heavy free users. They rely on conversion to paid tiers. If conversion fails, the wrapper dies. That death removes an API customer for the core provider. This is a feedback loop. Core provider revenue drops. It tightens access, raises prices. That causes more wrapper failures. The ecosystem contracts. Innovation slows. The market becomes fragile. The industry can collapse into a smaller set of services. The industry can collapse into a more centralized set of services. That concentration brings systemic risk. It also concentrates failures. A single major collapse could ripple through many sectors. The warning is stark. A major AI system can slip into a terminal state. Financial strain, model collapse, data poisoning, outages, real harms. The result is loss of trust. The cost is human and economic. Practical steps are clear and urgent. First, protect training data, track provenance, label synthetic content, remove or quarantine poison sources. Second, change economics, limit free tiers, avoid ads that distort incentives, charge sustainably for heavy use. Third, enforce safety audits, test on clinical vignettes and critical scenarios, require third-party audits, public transparency reports. Fourth, invest in human-created high-quality datasets, pay for curated content and expert annotations. Finally, regulate where necessary, require incident reporting, fund independent research on model collapse and poisoning, support robust monitoring tools. Act now. Delay deepens the damage. The silicon mind must be tended before it breaks.
The dead internet theory says, more of what I see online is generated by bots than I think. Whether that's true or not, my comment section can feel weird. So here's my 3-point bot checklist to spot a bot in your own comments fast. First, language fingerprints, hollow enthusiasm. If a comment is oddly generic, that's a flag. This changed my life. Such value. Thank you. Recycled phrasing. Bots echo viral templates. No one's talking about this. In 2026, this will age like fine wine. A strange combo of emojis that feels copy-pasted. Off-topic pivots. They react to keywords, not context. Mention signal. They argue about cell towers. Say model. They pitch AI trading, surface-level specifics. Ask for one concrete detail. What was the second example I gave? And see if they dodge. Quick test. Reply with a curveball. Cool. What was your favorite line at 4:12? Bots stumble on timestamps and specifics. Second, behavior and identity. Profile patterns. Look for thin accounts, new account, zero playlists, random stock photo, bio packed with hashtags, cadence, rapid replies at any hour across threads signal automation. Consistency. Bots keep the exact same tone, punctuation, and emojis. Engagement asymmetry. They drop one-liners and never expand. Quick test. Change the premise. I actually disagreed with myself by the end. Thoughts? Bots often keep insisting you said the first thing. Third, networks and intent. Link funnels, comments nudging you off platform, are classic bot goals. WhatsApp numbers, crypto sites, free templates, fake customer support, synchronized replies. 5 new accounts arrive minutes apart, boosting each other. That's coordination, keyword bait. They show up only under money, romance, or health shorts and steer to DMs. Promo clusters. Identical praise under unrelated videos with the same names. Quick test. Ask for safe, verifiable proof. Can you cite the study? Which section should I read first? Bots post screenshots. People summarize. How I respond. I slow down. Not every wrong opinion is a bot. I look for 2 or more checklist hits before acting. I de-incentivize. I avoid arguing in long chains. Starve the script. A simple reported for spam links ends it. I filter. I add common scam phrases to blocked words. I switch comments to hold for review on high-risk uploads. I test once, one targeted follow-up. If it dodges, I mute, block, and move on. Edge cases. ESL commenters may sound generic but be genuine. Accessibility tools can alter tone or punctuation. Some helpful bots clearly label themselves. Transparency matters more than origin. The point isn't to hunt witches, it's to protect attention. My feed gets better when I reward specifics. My feed gets better when I reward curiosity. My feed gets better when I reward accountability and ignore the rest. Recap, 3-point bot checklist. 1. Language fingerprints, generic praise. 1. Recycled lines. 1. Off-topic pivots. 1. Timestamp test. 1. Behavior and identity, cadence. 1. Consistency. 1. Thin profiles. 1. Premise change test. 1. Networks and intent, link funnels. 1. Synchronized boosts. 1. Keyword bait. 1. Ask for proof test. Try it on your next comment thread. You'll spot the patterns quickly, and you'll get your time back even faster. It is estimated that by the end of this century, the number of dead people on Facebook will outnumber the living. Think about that for a moment. The world's largest digital social gathering will become, in effect, a vast and sprawling cemetery. Conversations stopped mid-sentence. Birthday reminders pinging into the void. This is the new reality of our digital lives. We create these vibrant versions of ourselves online, noisy versions, colorful versions. But we have given very little thought to what happens when the person behind the screen is no longer there. The machine is not designed to let us go so easily. We are creating a world populated by ghosts. Not spectral apparitions of old stories, but digital apparitions, perfectly preserved profiles that linger long after their creators have passed on. A new digital purgatory, trapped online, active but ownerless. A quiet, unnerving corner of the internet, growing larger every single day. Leaving behind a trail of logins, photos, status updates. These accounts become monuments, often unintentional, left to the whims of algorithms and corporate policies. The mood is deeply unsettling, like walking through a town where all the lights are on, but nobody is home. pictures on the walls, letters on the table, faint echoes of past conversations. The inhabitants are gone, their homes are unintentional museums. This is what we have built. We have meticulously documented our lives, our thoughts, our friendships, our fleeting moments of joy, and handed them over to systems programmed for eternity. The internet, in its drive to remember everything, has forgotten the need to say goodbye and to let go. This essay explores that disquieting space. The primary reason our digital selves linger is surprisingly simple. The systems that run our online world are built for persistence, not for closure. They are designed to hold on to data forever. When you upload a photo or post a comment, the platform doesn't store it in one place. It creates duplicates, backups of backups, spread across countless servers all over the world. For reliability, so the service never loses your precious data. But this very feature becomes the mechanism that traps it after you are gone. Inactive accounts are rarely deleted. Even after long silence, deletion, being destructive and permanent, is avoided. So the account just sits there, searchable, visible, and counted. The default is indefinite preservation. Automated systems keep the network alive, people connected, and the data flowing, relentlessly. These systems are not sentient. They do not understand grief or loss. An algorithm will still suggest a deceased friend as a person you may know. It will cheerfully send birthday notifications, automated reminders of a day that now hurts. Not malice, just code executing without context. The digital graveyard is not peaceful. It hums with systems that treat the dead like silent, living users. Profiles are not static memorials. They are cogs in a machine still turning. The internet's architecture is built on accumulation and retention. Death was an afterthought, a human problem bolted onto a system that never planned for finality. And so the ghosts remain, not by choice, but by default. The technical systems are only part of the problem. They operate within a legal and policy vacuum. You agree to terms of service, a binding contract, almost no one reads. Buried clauses dictate your data's fate. You keep ownership but grant a license, one that often survives you. The law has not caught up. Families were blocked, privacy cited, while platforms kept using the data. Laws like the revised Uniform Fiduciary Access to Digital Assets Act offer frameworks, adopted unevenly. Executors can be empowered to manage digital property, but platform tools can override your will. A click can outrank a notarized document. The landscape is confusing and contradictory. Terms can change at any time. There is no universal right to digital inheritance. Treating the digital world like a frontier leaves grieving families fighting bureaucracy at the worst time. Beyond technical and legal reasons, there is a commercial incentive to keep dead users on the books. The modern internet runs on data and user numbers. Every account holds value, living or dead. 2 billion users sounds better than millions are deceased. Deleting accounts shrinks perceived market share. Your digital ghost is a valuable data asset. Your likes, connections, demographics, places retain value after you die, aggregated into models that predict the living. Your past preferences help target your surviving friends and family. Memorials draw visits, birthdays, anniversaries, memories. Each action is engagement. More time on site means more ads, so platforms have reasons to preserve. Deletion is harder, requires more documentation. Memorialization keeps data. Deletion erases it. The path of least resistance preserves the data, ensuring that even in death, you remain a user. The consequences are not abstract. They are human and painful. For many, a loved one's persistent presence feels like a wound that won't heal. Imagine losing a child, then months later receiving a cheerful suggestion to reconnect. On a late husband's birthday, dozens of automated messages arrive. These are not glitches. They are unfeeling moments of algorithmic pain. Comfort became compulsion, a way to avoid finality. The memorial page became a trap, replaying the past on loop. One man begged a faceless inbox, death certificate, marriage certificate, ID, while the public page stayed active. He felt powerless, as if a stranger controlled his wife's memory. We treat platforms as communities, sharing triumphs and struggles, but at life's end the mask drops. Not a community hall, but a data processing facility. A bureaucratic haunting after the real one. Identity theft thrives in the digital graveyard. Birth date, hometown, family, pet names, anecdotes, answers to security questions, treasure for criminals. A dead person won't notice a compromise. I'm stranded overseas. Can you send cash? Curiosity becomes compromise. A kind father's image twisted. Friends horrified. Weeks to shut it down. We lock homes after death. We need to lock digital doors too. Unmanaged accounts are open houses for memory theft. Platforms, laws, and we users share responsibility to demand better. We must begin with the systems themselves. Offer clear, accessible legacy settings. Prompt users yearly. What should happen to your account if you are no longer here? Default expiry options. Inactivity triggers memorialization or deletion automatically. Shift from endless preservation to planned closure. Build compassionate, efficient tools. No labyrinths, no anonymous uploads. Real support with clear steps. Small changes, big shift. From data accumulation to a life-centric model with a beginning, a middle, and an end. Design for departure as thoughtfully as we design for engagement. Design must be paired with stronger legal rights. Establish digital inheritance. Executors can access, manage, and delete accounts, like bank or property. Remove ambiguity that forces denials. Give families standing. A stronger posthumous right to be forgotten if the estate wishes. The internet is borderless. Laws must cross borders with shared principles. Reassert democratic control. Rules by public law, not opaque terms. Aim for universal dignity and control for every user, everywhere. By century's end, the dead may outnumber the living online. This is not just a number. It is unresolved stories, automated wishes, unmanaged memories. 1 billion digital houses with the lights left on long after everyone has gone home. We are brilliant at remembering, terrible at letting go. These ghosts persist for growth in a legal void driven by incentives and our silence. Do not leave the final chapter to an algorithm. Demand clear, simple, accessible tools. Choose whether to leave the light on or turn it off for good. The choice of how we are remembered should be ours. End with the candle in the phone, a reminder to decide now.
Is our nearest star hiding life? 4.2 light-years away, there's a tiny red sun hiding a giant question. Could Proxima Centauri host life? Here's the cosmic hook. Proxima is our closest stellar neighbor, and it's got at least one planet, Proxima b, parked in the so-called habitable zone. That means, in theory, liquid water could exist on its surface. Water plus time? That's the recipe we know best. But hold up. Proxima is a red dwarf, and red dwarfs are moody. They flare hard. X-rays, ultraviolet blasts, like a cosmic tanning bed set to oops. If Proxima b doesn't have a thick atmosphere, or a strong magnetic field, those flares could strip it bare. So, which way does it go? Let me break it down. Distance. 4.24 light-years. That's next door in space terms. Proxima b, roughly Earth-sized, in a tight 11-day orbit. Likely tidally locked, one side permanent day, the other eternal night. Other candidates. There's evidence for Proxima d closer in, and a debated outer world. Proxima c. Now, could life still find a foothold? Picture a twilight ring, the Terminator line where day meets night, not too hot, not too cold, with the right atmosphere, maybe CO2 rich, maybe with clouds that reflect some heat. That strip could be stable. Oceans could move warmth around. Volcanoes could recycle gases. A planetary magnetic field could deflect some of that stellar rage. Here's the payoff. We don't have to guess forever. We're building the tools to check. JWST is already sniffing atmospheres of small worlds. Proxima b is tough. It's too close to its star for JWST to isolate easily, but techniques are improving. The extremely large telescope will hunt for faint reflected light and gases like oxygen, methane, and carbon dioxide. The Habitable Worlds Observatory concept aims to look for chemical disequilibrium, like oxygen and methane coexisting, which screams active processes, maybe biology. Caveat time. Around red dwarfs, oxygen can show up without life, and methane can be geological. We'll need patterns, the ratios, seasons, and heat maps. Think of it like catching a glimpse of a city at night versus proving people live there. So, is Proxima alive? Odds are, if life exists, it's microscopic, hiding in oceans, soil, or that twilight band. Complex life. Harder but not impossible if the atmosphere holds and flares mellow over time. Here's why I'm excited. For the first time in human history, the nearest star might give us an answer. Not in centuries, in our lifetimes. Patterns in plain sight. They're hiding on your skin, in a sunflower, in the way galaxies spin. Today I'm revealing the mysterious power of sacred geometry, and why these shapes might be the blueprint of everything we know. Look at your fingerprint. Spirals. Zoom out to a hurricane. Spiral. Zoom way out to a galaxy. Spiral again. That repeating curve isn't a coincidence, it's a clue. Nature loves efficient patterns. The spiral, linked to the golden ratio, packs growth into the smallest space with the least energy. That's not magic, that's math wearing a cloak of mystery. Let's talk triangles. The triangle is the simplest stable shape. Engineers use it to keep bridges standing. Nature uses it too. Crystals, honeycombs, tiny molecular bonds. Stability is a pattern, and triangles are its signature. Now, the flower of life. It's a design built from overlapping circles, popping up in ancient temples, manuscripts, modern art. Some say it encodes the building blocks of reality. Whether you see legend or logic, here's what's undeniable. Symmetry, proportion, resonance, snowflakes, sound waves. Take the hexagon. Bees didn't hire architects, they figured out hexagons store the most honey with the least wax. Basalt columns, Saturn's polar storm. Efficiency, where's a hexagon? What about the golden ratio, Nautilus shells, Roman architecture, your phone's screen layout? Designers use it because our brains like balance. But here's the twist. The golden ratio isn't everywhere, forcing it is a myth. The real power is this. Proportion and harmony calm the mind. We're tuned to notice balance. So does sacred geometry have power? Absolutely. Just not the kind that levitates rocks. Its power is how patterns guide energy, growth, and attention. Architects align buildings to light. Musicians map harmonies with ratios. Even your heartbeat has a fractal rhythm. Complex, yet ordered. Try this. Next time you're outside, find 5 patterns. Spiral in a pine cone, hexagon in a snowflake photo, symmetry in a leaf, triangle in a roof truss, grid in city streets. You'll feel it. Order inside chaos. Want to bring that into your space? Use odd number groupings on shelves. Aim for balanced proportions in room layout. Pick a focal triangle, big, medium, small. Your brain relaxes when geometry whispers, this makes sense, and if you're curious, sketch the seed of life. 1 circle, then 6 around it. Watch more circles birth the flower of life, the Vesica Piscis, the blueprint for a cube. It's a rabbit hole where art meets physics. Here's the secret. Sacred geometry isn't about believing in magic. It's about seeing the math of beauty, the rhythm of growth, the symmetry of life, patterns in plain sight. Once you notice them, you can't unsee them. Look around. The universe is drawing. And now, you can read it.
Are you the last real person in this feed? If that question made your stomach drop, good. Because today I'm testing a theory. Most of what you see online isn't human. It's bots. Surveillance systems trained to look like us, talk like us, and steer what we do next. But I'm not here to panic you. I want to know right now how human your feed really is, and whether you're being profiled by machines more than you think. Let's run a 5-minute audit together. Step 1. Reaction lag. Post something boring but oddly specific, like trying to fix a squeaky door at 2:17 a.m., then watch. Humans trickle in with context jokes or silence. Bots show up fast, vague, and off-topic. Amazing, so true, or a random emoji storm. Step 2. Comment depth check. Open any heated thread. Click a profile from a top comment, then another, then another. 3 hops deep. If the language becomes generic, the avatars suspiciously pristine, and the posting times weirdly uniform, you've likely drifted into a synthetic cluster. Step 3. Pattern break. For 48 hours, interact with things you never touch. Birdwatching Mongolian throats singing antique calculators. If your feed snaps to a whole new identity in under a day, and then hard locks there, that's the surveillant layer rewriting your you. Step 4. Provenance. Take a viral image and reverse search it. If the earliest hits are low-karma forums, scraped sites, or a dozen accounts posting the same asset within minutes, that's coordination, likely automated. Step 5. Time symmetry. Real people sleep, work, disappear. Sample 5 accounts you see daily. If 2 or more post at near-perfect intervals across time zones with no weekends or holidays, you're looking at scheduled presence. Step 6. Link entropy. Humans wander, bots funnel. If a cluster keeps pointing to the same domain, families link shorteners or tracking parameters. That's a sign of a campaign, not a conversation. Step 7. Off-platform reality. Pick 3 friends or frequent commenters. Can you verify one offline artifact, school site event photo, local tag, or a non-commercial footprint? No? They might be vapor. Here's the twist. Some of these systems are built to watch you watch them. If your ad topics change after you merely hover over a post, if your For You recovers instantly after you try to detox, you're not just seeing the internet, you're training it. So are you the last real person here? Probably not. But you can be the most awake. Curate deliberately. Follow creators who show work in progress, not just polish. Comment with specifics that AI struggles to fake. Dates, places, personal context. Mute vague accounts. Star real friends. And once a week, do a pattern break to reset the profile built on you. Your feed is a mirror that learns. If you don't teach it, someone or something will. Now check your last 10 posts. Count the real. What if Jupiter isn't just a planet, but a firewall? A colossal, swirling guardian that keeps our world playable. If we're living in a simulation, why would the coders leave Earth exposed to cosmic chaos? When a single gas giant could keep the frame rate steady? Jupiter is 318 Earths of gravity well. It tugs, deflects, and devours. In 1994, the comet Shoemaker-Levy 9 shattered and slammed into Jupiter, leaving Earth-sized bruises in its clouds. That impact wasn't just a spectacle, it was a hint. Something big stands between us and a lot of unwelcome endings. I like to think of Jupiter as the universe's spam filter. Most of the junk, long-period comets from the Oort cloud wandering asteroids nudged by resonance gets flagged, rerouted, or deleted. Not perfectly, but enough to keep complex life's uptime high. Now roll with this. If this is a simulation optimized for interesting results, not constant catastrophe, wouldn't you implement planetary sentinels? Efficient systems don't brute force randomness. They sandbox it. Jupiter's mass concentrates risk. It catches the loud mistakes so the simulation doesn't waste compute rendering extinction events every few million years. And Jupiter doesn't just block, it organizes. Look at the Trojan asteroids riding safely at its Lagrange points traffic tucked into gravity's slipstreams. Look at orbital resonances shaping the asteroid belt, clearing hazardous lanes and seeding stable ones. It's like someone optimized the map. Here's the twist. Too much Jupiter is bad. Hot Jupiters migrating inward can erase rocky worlds. Too little, and the inner system gets pelted endlessly. Our Jupiter sits far out, massive but not marauding, with Saturn as a co-shepherd. That's a Goldilocks parameter. Maybe evolution found it, or maybe someone said it. The anthropic view says, of course we find ourselves in a system friendly to us. Where else could we exist? The simulation view adds a design constraint. Of course, the coders reduce non-productive randomness. Why spend cycles on noise when you can invest them in emergent behavior like minds, art, and late-night videos asking strange questions? Am I saying Jupiter proves the simulation? No. I'm saying Jupiter is suspiciously useful. A gas giant exactly where you'd place a shield in a level editor. A boss-sized bouncer at the edge of the dance floor, letting the fragile groove of life keep time. So next time you see that bright dot low in the night sky, imagine the log file. Impact attempts, quarantined. Rogue comets, redirected. Earth, still rendering. And here's the bigger question. Whether or not this is code, what do you do with the time that Jupiter buys you? If a planet is out there taking the hits, maybe the best answer is simple. Use the quiet to build something worth protecting. I'll leave you with this. In a noisy universe, silence isn't an accident. Sometimes it's a feature. Look up and listen.
Think you've got galaxies figured out? Cool, because I'm about to surprise you 5 times in a row. Let's dive in. Fact 1. Most galaxies are tiny and nearly invisible. When people picture galaxies, they think of giant spirals like the Milky Way. But most galaxies out there are dwarfs. A few thousand light-years across, with just a few million stars. They're so faint they hide in plain sight. Our own galaxy is surrounded by dozens of ultra-faint companions you can't see without serious telescopes. These little guys are the quiet majority of the cosmos. Fact 2. Galaxy collisions are epic, but mostly silent. Galaxies look like they smash together, but stars are so far apart that direct star-on-star crashes are rare. Instead, gravity does the heavy lifting, stretching, warping, flinging stars into long tidal tails. In about 4 billion years, the Milky Way and Andromeda will merge into a new supergalaxy. Don't panic. No fiery skyfall, just a slow celestial dance that takes billions of years. Fact 3. Some galaxies barely have stars, yet they're huge. Meet ultra-diffuse galaxies. They can be Milky Way-sized but incredibly dim, with their stars spread so thin you can see right through them. Many seem loaded with dark matter, which acts like scaffolding to hold them together. Imagine a ghost city, full-size streets, almost no lights on. Fact 4. And some galaxies seem to have almost no dark matter at all. Yep, the opposite exists too. Astronomers found oddballs where the stars and gas alone explain their motions. No extra dark matter needed. It's a curveball for our models, hinting that galaxy formation is messier than a simple one-size-fits-all. Same universe, totally different blueprints. Fact 5. Black holes don't eat galaxies. They help run them. At most, big galaxies' centers sit supermassive black holes, millions to billions of times the sun's mass. They're not cosmic vacuum cleaners, they're thermostats. When they feed, they fire jets and winds that heat or blow out gas, slowing star formation. When they quiet down, galaxies can cool and grow new stars again. It's a delicate feedback loop that shapes how galaxies live, age, and fade. Bonus mindbender. A lot of stars live between galaxies. In dense clusters, gravity tides strip stars from their homes, leaving them drifting as intra-cluster light. Entire Milky Way's worth of stars can be spread like cosmic fog between galaxies. Here's the takeaway. Galaxies aren't just pinwheel postcards, they're dynamic ecosystems, colliding, recycling, evolving with help from invisible matter and heavyweight black holes. The next time you see a gorgeous spiral photo, remember, there's a whole hidden population of faint dwarfs, ghostly giants, orphan stars rewriting what a galaxy can be. If that surprised you, imagine what the next sky survey will reveal. Hit subscribe, because the universe is not done blowing our mind. What if the story we have been told about our own biology is fundamentally incomplete? For decades, scientists have looked at the vast, sprawling code of human DNA. Only about 2% contains the direct instructions for building the proteins that make up our bodies. Visualize the rest. A staggering 98%. Dismissed. It was labeled junk DNA, useless evolutionary debris, or so it seemed. But what if that assumption is profoundly wrong? What if the junk is not junk at all? This question opens a door into a deep, compelling mystery. Imagine a library where 98% of the books are in a language no one can read. Would you assume nonsense? Or suspect encryption, waiting for a key? The new perspective, vast non-coding DNA as biological software, a complex operating system we haven't learned to run. To grasp this, we must change how we think about DNA. The old view, a cookbook. Each gene is a recipe for a single protein. The cell reads the recipe and cooks up the protein. True, but only a small part of the story. The so-called junk DNA might be the master chef. It decides which recipe to use and when. It decides how much to make. It coordinates the whole, a coherent, functional meal, a control system of staggering complexity. Small segments act as powerful switches, on in the brain, off in the liver. Active in development, silenced later for life. Not a wasteland, a bustling metropolis of regulation. Let us take this further. What if it's a form of biological encryption? Encryption encodes information so only authorized keys can read it. Meaning requires a key. Perhaps those stretches hold encrypted programs and data, locked away, waiting for specific biological keys. A molecule could be a key. An environmental signal could be a key. A developmental stage could be a key. Encryption offers stability and safety. It prevents accidental activation of powerful routines in the wrong context. Dormant until called. A masterful system of information management. The clues to this encrypted reality may not only be found in a laboratory. Consider deep general anesthesia. Normal consciousness switches off, networks quiet. Some describe entering a white room, uniformly bright, featureless, empty, not a dream, profoundly real, minimal pure, a baseline, a default state of being, the perceptual signature of bedrock consciousness, the simplest feeling, I exist. Section 5, the neon illusion. A filter on reality. In deep meditation, sensory deprivation, or waking from anesthesia, a faint shimmer appears, a neon haze, a glowing veil, not a hallucination, more like noticing the filter itself. Our brains craft a clean, stable, coherent reality, filling gaps, smoothing motion, filtering noise. The neon illusion may be the raw edge of that processing, perhaps a manifestation of the brain's own energetic field, or an artifact of an encrypted DNA operating system interfacing with sensory hardware. A carrier wave, usually invisible, revealed in special conditions. We may live inside a finely crafted biological simulation, seeing the pixels for a moment, not false, just revealing the hidden machinery. If consciousness is biological software, it can have bugs, trauma, injury, extreme psychological stress, holes in the sense of self, memory loss, dissociation, fragmentation. Yet through the cracks, something luminous persists. Enter the consciousness patch, a pre-encoded routine to restore integrity. Like a software update, automatic, deep-level repair. When primary systems falter, the patch deploys from encrypted DNA. It restores baseline self, fills gaps, re-establishes a foundation. The white room in anesthesia, a minimal holding pattern. You are here, safe, you exist. The neon haze may reveal seams during repair, the biological equivalent of a loading screen, a built-in framework for resilience. Mending minds from the code up. Encrypted code reframes evolution, beyond slow, random mutations and gradual selection. The record shows sudden jumps and new forms. Biological encryption offers an explanation. What if species archive old programs, encrypted in non-coding DNA? A massive code library of dormant traits and functions, evolution at 2 speeds, slow coding changes, and a fast track from stored programs. Environmental shifts could provide keys to unlock archived code, traits dormant for millennia, rapidly reactivated. Not invention from scratch, but loading from an internal library. The 98% becomes collective memory, a hard drive of adaptations, a toolkit of futures. Encrypted code and consciousness patches echo through culture. They speak of inner light and primordial awareness, simple, pure, foundational states, clear light, the void, the ground of being, descriptions mirroring the modern white room, practices as keys to deeper software layers. Quiet the dominant program, glimpse the consciousness patch, modern metaphors for an ancient veil, Maya reimagined, a scientific interpretation of illusion, the constructed interface. Ancient wisdom meets genetics and neuroscience. Different facets of one truth, hidden biological code, shaping body and being. We stand at a fascinating threshold. The junk myth is crumbling, elegance emerges. An encrypted operating system is a testable hypothesis. Clues across fields, regulatory RNAs, edge of consciousness reports, ancient echoes. A theory, a map for exploration. Connect molecular biology with subjective experience. Develop tools for keys. Listen to outliers and anesthesia messages. The implications are immense. Healing body and mind by reading hidden code. A journey into ourselves, a language written for billions of years. The story is unfolding. Will we find the keys, read the encrypted software, understand the patches, and see past the gentle illusion?
I'm going to say it straight. We're at 99.9% certainty the object is interstellar. That means it came from outside our solar system, slipped in, is now on its way out. Here's the mystery, and the proof. First clue, the path. Its orbit isn't an ellipse like planets and comets we know. It's hyperbolic with an eccentricity greater than 1. Translation: it's moving too fast to be captured by the sun's gravity. Even far from the sun, it keeps a bonus speed, what astronomers call hyperbolic excess velocity. Second clue, the direction. It's diving in from a random angle not lined up with the flat plane where most planets travel. Solar system objects are team players. This one is a drifter. Third clue, the speed. Crunch the numbers and you get a velocity at infinity that the sun didn't give it, and couldn't take away. So, how do we get to 99.9%? By fitting thousands of orbits to the data, Monte Carlo style, and every solution screams not bound. We measure its position night after night across multiple observatories and triangulate its motion with parallax. We check the light curve, how it brightens and dims to see if it's tumbling, icy, rocky, or dusty. If there's a tiny push that gravity can't explain, we look for outgassing or sunlight pressure. Spectra tell us what it's made of: radar. If we can path, direction, speed, they line up. That's how we reach 99.9%. The object is interstellar. I'm standing at the edge of a trail that disappears into a wall of trees. People walk in, smiling, posting selfies, and sometimes they just don't come back. Today, I'm talking about the 411 code, why people vanish in national parks, the places some hikers call the no-clip zones. I'm not here to sensationalize. I'm here to ask the question that gnaws at you when the forest goes quiet. How do people become ghosts in places mapped, patrolled, and loved by millions? Let's start with the patterns. Granite, boulder fields, swift creeks, sudden weather shifts, fog rolling in like a curtain, a toddler who wanders 30 yards and is found miles uphill. A seasoned hiker steps off trail for a minute, gone. When search teams arrive, sometimes the dogs lose the scent, like the air itself has no memory. Now zoom in on the human element. Parks are big, bigger than your sense of scale. A wrong turn on an unmarked spur can become a labyrinth. Panic is a predator. You start moving faster to feel better, and you drift further from anyone who could help. Sound dampens in trees and canyons. You can scream and be 100 yards from a trail and no one hears you. There are rational explanations, and they are not comforting. Hypothermia can make you undress. A slip-on scree can hide you under brush. Water erases tracks. Predators and scavengers reduce clues to almost nothing, fast. Technology fails. Batteries die, GPS glitches, phones go from lifeline to paperweight. Shoes found neatly placed, clothing folded, a body recovered in an area searched 3 times. You can call these search errors randomness, the mind stitching patterns into noise. Or you can admit, some cases resist tidy endings. Rangers will tell you the same thing in steady voices. Trails are suggestions, nature is law. The environment is indifferent, and it punishes small mistakes with big consequences. Most disappearances aren't conspiracies. They're compound failures. Navigation, weather, health, time. So why no-clip zones? In games, no-clip lets you pass through walls. In the backcountry, the walls aren't brick, they're perception. Fog erases depth. Snow flattens landmarks. The map in your head goes out of bounds and you step into a place your senses can't parse. That's where people vanish. Not into portals, but into the gaps between attention and environment. If you ever step into these places, make a pact with yourself. Tell someone your plan and your turn-back time. Paper map, compass, GPS or PLB, extra layers, water, whistle, light. Stay on trail when you're tired, and when the weather turns, you turn too. If you're lost, stop, breathe, build a signal. Let rescuers find you. The forest isn't out to get you, but it doesn't care if you're clever, brave, or trending. Respect it, and you'll leave with stories. Forget that, and you might become one. I hope you make it home, and I hope we keep asking hard questions about the cases that don't, because answers matter, especially when silence feels like part of the mystery. I'm opening a cold case from tech history. The so-called 2014 dead drop. The secret AI integration nobody noticed. Here's the twist. No credible record shows that event actually happened. But 2014 did hide real moves that changed AI and security quietly for years. Start with a headline that did happen. Google paid more than $600 million for DeepMind. That wasn't just a purchase, it was a signal. The smartest minds in reinforcement learning were about to get massive compute, data, and a mandate. The same year, IBM began producing a prototype brain-inspired chip, hardware designed to scale learning efficiently. Think of it as building the road while the race cars roll out. Now, why does this feed the secret integration myth? Because when breakthroughs stack up fast, most of it stays inside labs, government programs, and research circles. A lot flew under the radar. Meanwhile, a different kind of stealth was unfolding in cybersecurity. Operation Ghost Dukes, likely starting in 2013, targeted government entities for years with barely a ripple. One reason? Dead drop resolvers, using public platforms like Twitter, Imgur, Reddit as hidden beacons to retrieve instructions. It's old spycraft modernized, and yes, it's still effective. Put those threads together. Quiet AI leaps, covert digital tradecraft. It's easy to imagine a dramatic dead drop moment when AI slipped into everything unnoticed. But the reality is more granular and more interesting. Here's the pattern I see. First, capability jumps. Image recognition got good enough that a Google-bound engineer warned our privacy instincts must change, now that machines can decipher images. Second, infrastructure matured. Specialized chips, cloud scale, data pipelines. Third, adversaries adapted. Dead drops went from park benches to public URLs, then to algorithms reading those URLs. By 2024, people were talking about neural networks predicting stash locations from movement patterns and social media. Hackers testing models like GPT-4 to plant fake trails. Noise to jam the signal. Is every claim verified? No. But the direction is clear. The cat and mouse game is now algorithmic. So was there a single 2014 dead drop no one noticed? No credible sources say so. What we did miss, collectively, was the slow fuse. Deals, chips, datasets, quiet operations that set conditions for today's AI everywhere world.
I'm going to start with a simple question. Does Earth secretly have a second moon? Kind of. That's where the story gets wild. Today, 2025. PN7, Earth's newest quasi-moon candidate. Telescopes in 2025 flagged a small object. It tracked our sky for months, suspiciously close on the cosmic highway. It doesn't orbit Earth like the moon. It orbits the sun. So why does it hang around us? Co-orbital dynamics. Imagine Earth and this object running laps in the same lane. A delicate gravitational dance keeps it near our neighborhood. From Earth it looks like a loop, drifting ahead, falling behind, drawing lazy corkscrews across the sky. That's a quasi-moon, not captured, but synchronized. Kamo Oalewa. 2023. FW13. 2025. PN7 is the latest in that lineup. It's small, dozens to a few hundred feet across, too faint for the naked eye, but visible to big telescopes. It may stick around for years, then drift off and return later. What makes a quasi-moon special? First, a natural lab for celestial mechanics. Second, origin questions. leftover shard from the early solar system, a fragment of a larger asteroid, or a piece of lunar rock. Third, opportunity, shorter missions, less fuel, big science. How do we learn more? We watch. Photometry, brightness and spin clues, spectra, mineral fingerprints, radar, size and precise path. Each pass refines the orbit and confirms companionship. Is it dangerous? No. They're travelers, not crashers. Nearby, not on a collision course. They're cosmic signposts. Earth doesn't fly alone. 2025 PN7 looks like a genuine co-orbital companion, a temporary +1. Clarity will come from current data and its next brightening. Follow the Minor Planet Center circulars, check JPL's small body database, watch survey updates. Even a pebble can tell a big story about how worlds share space. The Matrix, just, glitched. I asked an AI to break the code of reality, and in the first 5 seconds it found something that should not exist. Countdown starts now. 5, 4, 3, 2, 1, go. Okay, listen close. Live traffic, stock ticks, bird migrations, satellite clouds, city microphones, earthquake sensors, legal public feeds only. The goal? Find patterns humans miss. I hit run, and in the first 5 seconds, the model froze the screen and flagged a code word, echo. Echo meant repeats. Same cars looping different streets. Same footsteps at identical intervals across cities. Same cloud swirls over oceans hours apart. The AI highlighted them in neon, like the world copy-pasted itself. Subtitle, Pattern 1, Clockwork Breath. That's what it called the rhythm of everything. Traffic pulses, power grids, even my own mic audio, locked to a hidden beat at 1.618 Hz, the golden ratio. Not once, thousands of streams, synced. Coincidence? Or code? Subtitle, Pattern 2, NPC pathing. Crosswalk cams showed people pausing, step-stepping, then committing, all within a 6-frame window. Different people, same timing, like invisible rails. Subtitle, Pattern 3, Sky duplicates. The AI screenshot 2 cloud frames, 12 hours apart, 3,000 miles away. Pixel-matched spirals, 94% identical. Weather doesn't do copy-paste. Code does. At second 4, the AI screamed portal. Not a sci-fi hole in the sky, a gap in probabilities. Markets, traffic, birds, Wi-Fi noise. Everything dipped, then snapped back, like reality took a breath, a universal hiccup. At second 5, it showed me the weirdest thing, a tiny delay, 42 milliseconds, rippling across multiple live feeds. Cameras on different continents blinked late, same offset. The AI labeled it, frame tax. Like the world paid for a patch update. I know, it sounds insane, so I tried to break it. New data, new cities, offline recordings, same rhythm, same rails, same frame tax. Then I asked the AI one question, if this is a sim, what's the tell? It answered with one word, choice. So I tested it live. I flipped a coin on camera and decided I'd do the opposite of whatever it said. Heads, I'd go left, but I went right. The AI's prediction stream glitched and reloaded. The clockwork breath went out of sync for exactly 7 seconds. When I acted random, the beat broke. So what did the AI see in the first 5 seconds? Not a door out, a mirror. A rhythm we fall into without noticing. Until we don't. Here's my challenge. For the next 24 hours, break the pattern, switch your route, answer with your offhand, stare at the sky for 10 seconds for no reason. Tell me what desyncs.
Picture your body like a powerful computer. When surgery needs to dive deep, I switch you into safe mode. That's anesthesia. Safe mode strips out distractions, protects critical files, keeps the system stable while techs work under the hood. In your body, that means I quiet pain, memory, movement, stress. Not off, not gone, just guarded. There are 3 big switches. 1, awareness. I dim the screen, your conscious experience, so you won't form memories. 2, sensation. I mute pain pathways so alarms don't blare. 3, motion. I pause muscle activity so the workspace is still and safe. How do I toggle them? with combinations like a careful keyboard shortcut. Fast-acting sedative fades the desktop. Analgesic silences the error pings. Muscle relaxant stops background apps, your reflexes. Breathable anesthetic, a steady system update to keep things smooth. Safe mode only matters if the system stays protected. So I monitor constantly. Oxygen levels, live picture of your fuel, blood pressure and heart tracing, power supply coping. Capnography tracks your exhale, temperature, fluids, brainwave depth, sometimes. Redundancy is the point. Airway is the main cable. I secure it, I confirm it, I watch it like a hawk. Secretions, swelling, a shift. I see it on the waveforms before it becomes a headline. Before we ever boot into safe mode, I run a pre-op checklist. Allergies, meds, past anesthesia stories. I plan the route, the backup route, the backup to the backup. In the room, we do a timeout. Right person, right procedure, right side. Anesthesia today is safer than it has ever been. Not because risk vanished, but because layers of process catch small errors before they stack. Doses are titrated, machines self-check. I never trust a single number without context. Waking up is a controlled reboot. I lighten the gas. What if the universe isn't empty, just efficient at deleting its players? Today, I'm chasing a riddle with teeth. The Great Filter. It's the idea that somewhere between the spark of life and a civilization crossing the stars, there's a trap so lethal that almost no one gets past it. Look around. Hundreds of billions of stars in our galaxy, trillions of galaxies across the universe. If life is common, space should be buzzing, but it's quiet. So, what is the system deleting? Maybe the filter is behind us. Life could be nearly impossible. Right chemistry, right environment, right cosmic luck. Single cells, complex cells, multicellular life intelligence. We might be rare and safe. Or the filter is ahead. Every species as a player climbing a staircase. At the top, interstellar life, safe from local disasters. On the way up, a gauntlet. First, self-sabotage, nuclear fire, engineered plagues, runaway AI, climate collapse. The same intelligence that builds rockets also builds traps. Second, resource ceilings. You need energy to grow. The easy energy goes first. Soil, water, fossil fuels. If a society burns through its capital before mastering scalable, clean power, it stalls. Third, cosmic ambushes. Supervolcanoes, asteroid impacts, gamma-ray bursts. If your species is confined to one world, one bad century can erase a million good ones. Fourth, complexity overload, bureaucracy, misinformation, polarization, and then the spookiest possibility, filters we can't see. Maybe faster than light travel is impossible. Maybe intelligence digitizes into quiet virtual worlds. Maybe successful players hide. The universe rewards silence. So which is it? Behind us or ahead? Here's the clue. Timelines. We've been technological for a few centuries. A blink. If the path were easy, someone else would have blinked and announced themselves. No one has. Maybe the staircase narrows right where we stand. If that's true, survival is a project, not a vibe. Align incentives, reduce existential risks, scale clean energy, automate without surrendering agency, build resilience, go multi-planet. Test ideas like our lives depend on them. Or maybe we already passed the worst. If we're rare, our job is to make it. The Great Filter is a mirror. Can a species become powerful without becoming careless? Can curiosity outrun self-destruction? I don't know where the filter is. The only way to find out is to keep climbing, carefully, together, and soon. Imagine waking up in 2025 and realizing reality rebooted, not crashed, hot rebooted. Subtle icons swapped, memories misaligned, timelines forked. That's the claim behind a fresh wave of Mandela effects lighting up TikTok right now, and I wanted to see if any of it holds up. Here's the hook: timeline shifts. Brand tweaks new angles on the JFK assassination. One viral claim goes further. In this reality, there are no Epstein files. Everyday glitches, confusion over where your kidneys sit. Whether the Pringles guy always looked like that. So what's going on? Reality's bad version control, the theory riding the algorithm. The Mandela effect isn't faulty memory. It's claimed as evidence we're in a frantically patched simulation. Timeline forks, sloppy multiverse merges, forgotten cornucopias, phantom monocles. Some point to physics moments, like LHC reboots, as the commit that split our branch. It's clever, it's fun, it's up against heavy hitters. If a universe is a simulation, it must be algorithmic, fixed rules. UBC researchers say the fundamental layer looks non-algorithmic, mathematically incompatible. If they're right, the simulation pitch doesn't compile. Memory science isn't on Team Glitch. A University of Chicago study found people share confident false memories, like Pikachu's tail tip, that never existed. Consistent misremembering makes the illusion feel real. Fruit of the loom cornucopia. A 2022 poll found most Americans think it's there. It never was. The brain constructs patterns to make sense of fruit arrangements. Patterns over precision. So is the hot reboot real, or are we persuasive to ourselves? AI is a new wildcard. Generative tools conjure plausible fakes, remix logos, and seed visuals that match biases. Experts warn a crisp fake can enter the feed, then your memory. I'm not here to kill the wonder. Reality feels drafty sometimes. That's why parallel existence and glitch theories resonate. Toolkit for 2025. Screenshot first, react later. Look for primary sources, not stitches. Ask whether the claim explains more than it assumes. Compare across time. Archive.org. If there was a hot reboot, expect deep testable discontinuities, not just fuzzy icons. Until then, human memory, plus viral culture, plus powerful tools is the cleanest explanation. If you've noticed something odd, drop it in the comments with receipts. Maybe it's a glitch, maybe it's us. Either way, look closer. I'm keeping my mind open, and my screenshots handy.
Alright, let's talk aliens. Not lights in the sky. A map. Betty and Barney Hill, 1961. They claimed they were taken aboard a craft in New Hampshire. Under hypnosis, Betty drew a strange star map. Dots, lines, trade routes, a cosmic subway. Here's the wild part. Years later, Marjorie Fish tried to decode it. She built 3D models of nearby stars, strings beads, hanging from her ceiling. Line up the model just right. The pattern snapped into place. Fish's best match? Zeta Reticuli, a binary star system about 39 light-years away. 2 suns, both sun-like. A quiet neighborhood. In the 1960s, that seemed like prime real estate for life. If trade routes were real, they connected Zeta to nearby suns. A map of local interstellar highways. So, did Betty Hill secretly sketch our cosmic backyard from an alien screen? Or did we see meaning in random dots? Let me break the skeptic's side down. First, selection bias. If you try enough angles, enough distances, you can make a lot of dots look like a match. Second, the data changed. The star catalogs in the 60s were missing accurate distances for many dim nearby stars. As astronomy improved, some of Fish's key alignments faded. Third, the map itself is ambiguous. No scale bar, no clear orientation, just dots and lines, but the believer side has its punch too. They ask, why did Betty draw sun-like stars near us? How did a New Hampshire social worker produce a pattern? A teacher years later could overlay on a real 3D star field. And what about Zeta Reticuli? 2 stable suns in a low-dust region with long-term stellar calm. Here's what I think. The map is a masterclass in human pattern finding. It's a Rorschach test for the cosmos. Rotation, scale, which stars to include, and yet. The story endures because it asks a delicious question. If someone did visit, what would their navigation look like? Modern astronomy lets me check this with better data. Gaia has pinned down distances and positions for over 1 billion stars. When researchers recreate the hill map using today's nearby sun-like stars, the perfect match slips. It's close enough to intrigue, not close enough to convince. So, did aliens visit? The Betty Hill map doesn't prove it, but it does something just as powerful. It makes me look up and wonder. If a civilization did build trade routes, they'd almost certainly link sun-like stars with quiet neighborhoods. The same places we're now targeting with telescopes and radio listens. Your turn. Does the Zeta Reticuli match feel like coincidence? Or a clue? Tell me in the comments. If you love smart, weird mysteries like this, tap subscribe. And let's keep chasing the unknown, one dot and line at a time.
They say the Piri Rice map holds GPS data from a lost civilization before the last reset. Bold claim. Let's test it. Myth versus fact. Myth. 1513 map shows Antarctica ice-free. Fact. It's a composite Atlantic chart by Ottoman Admiral Piri Rice, stitched from older sources, Portuguese sources, Arabic sources. He even wrote his sources on the map. The Antarctica is likely South America's tail drawn too far east and south, a common pre-longitude error. Myth. Coastlines too accurate for sailors. Fact. Portolan charts built from thousands of coastal bearings. Dead reckoning. The magnetic compass. Accuracy hugs coasts, then fails inland, exactly what shipboard mapping looks like. Myth. Hidden latitude-longitude grids. GPS. Fact. No secret grid. Early charts used windroses, rum lines, spiderweb sailing lines for constant compass headings. Longitude was notoriously hard until the 1700s. That skews South America, a longitude problem, not laser scans. Myth. Piri copied a pre-flood world. Fact. He names his sources. Maps from Alexander's time. New Portuguese maps. A map by Columbus. This points to a library of charts, traded, stolen, updated during the Age of Discovery. What makes the map special? It captures a moment when information was power. Empires hoarded charts like gold. Piri had access to captured Portuguese maps. He compiled data onto gazelle skin. It's a snapshot of real history sailors stitching the world voyage by voyage. The ice-free Antarctica claim? Compare coastlines. The fit falls apart. The scale is off. Orientation drifts. Crucial features missing. But the Caribbean lines up with Columbus. That's contemporary intel, not ancient satellites. System failure. That's what it felt like the day ChatGPT went dark for hours. Millions of people stared at blank screens. Today, I'm asking a hard question. Is AI's hottest company bleeding out? Here's the thesis. OpenAI is racing to build the future, while its balance sheet is racing the clock. According to Windows Central, internal docs project a $14 billion loss in 2026. $14 billion. The costs? Huge infrastructure build-outs, model training, research hiring, and compute bills that alone hit about $1.4 billion. Even with roughly $13 billion in annual revenue from ChatGPT, that math doesn't pencil out. Analysts warn the cash runway could end by mid-2027 without fresh funding. Meanwhile, the moat is leaking. R&D World reports ChatGPT's market share slid from 86.7% to 64.5% in a year, while Google's Gemini climbed to 21.5%. Stack that on top of repeated outages, including a 15-plus hour global disruption, and you've got trust erosion at scale. Tom's Guide logged over 10,000 error reports in a single day, with chat histories vanishing and basic features breaking. Then there's the shock from China. Sahi Analytics says DeepSeek built frontier-level AI for around $6 million. $6 million versus the tens of billions OpenAI is spending. That news coincided with NVIDIA's biggest single-day market cap loss, about $600 billion, underscoring how fragile the AI hype cycle can be. The legal and financial storm clouds are also gathering. Cyber News reports industry experts think OpenAI might not survive 2026, pointing to a $134 billion fraud lawsuit from Elon Musk and the rollout of ads, something CEO Sam Altman previously called a last resort. And Wikipedia's summary of projections says OpenAI could burn roughly $115 billion through 2029, $17 billion in 2026, $35 billion in 2027, $45 billion in 2028. So what's really happening? To me, this looks like a race with 3 finish lines. Build a model so good it becomes indispensable. Find a business model that actually pays for the compute. Keep the lights on long enough to do both. If DeepSeek can push the frontier at a fraction of the cost, the era of spend your way to a moat might be over. If outages keep stacking, enterprise confidence will follow the exits. And if the runway shrinks, optionality disappears. Fast. But here's the twist. Markets can pivot. Funding can flood in. Cheaper inference, a killer app, a real platform lock-in can flip the narrative overnight. For now, the signal is clear. The next chapter of AI won't be won by the loudest demo. It'll be won by the cheapest reliable token, the most resilient uptime, and the business model that survives the storm. I'm watching the dashboards. Uptime, unit economics, and trust. Because if ChatGPT's terminal error is just a warning, there's still time to recompile the future.
In 2020, Comet Atlas disintegrated as it approached Earth. That is the official story. It is a lie. Atlas didn't fall apart. It deployed. NASA mistook a controlled separation mechanism for a natural breakup. Comets are ice and rock. They follow gravity. Atlas did not. Before it shattered, it altered its velocity by 0.02%. That is impossible for a rock. That is intelligent propulsion. It was the exact same maneuver used by Oumuamua years earlier. But Atlas was 50 times larger. It wasn't a scout, it was a carrier. Look closely at the debris. They didn't scatter randomly, they maintained a grid formation. These aren't rocks, they are autonomous probes released into our solar system to scan us. Just moments before the breakup, radio telescopes picked up a massive spike in data transmission. It wasn't interference, it was a sync signal. The carrier was uploading targeting data to the swarm. Where are the fragments now? They are dark, silent, orbiting Earth disguised as space junk. They are waiting for the next command. The system is being watched from the inside. Atlas was named after the Titan who held up the sky. This craft didn't come to hold us up, it came to check the cage, to see if humanity has broken the quarantine code. The swarm is active, we have intercepted the signal frequency. Subscribe to Crypto's code, and we will track the fragments. Check our shorts to see the leaked footage NASA deleted.
People keep asking me about a whisper from the web. The 2014 ghost, the AI that started writing the internet. It sounds like an origin story, a secret model, switched on once, then left to haunt our feeds. So I went looking. First breadcrumb, 2014. A big year for AI, no doubt. Assistants were rolling out to early users. Deep learning was breaking out of labs. But a name system? The 2014 ghost? I found rumors, Reddit threads, stray Medium posts. Nothing verifiable. No paper. No demo. No changelog. If it changed the internet, it somehow left 0 fingerprints. That's not how breakthroughs behave. So I pulled at threads that did exist. In 2014, generative adversarial networks, GANs, arrived. Powerful for images, not text. Recurrent neural nets had been writing short, weird sentences even earlier. In industry, assistants matured. Tools got better, but they weren't ghostwriting the web. There's no credible mention of a system with that name in any conference, repo, or press release. I checked. A lot. Second breadcrumb. Maybe the 2014 ghost wasn't a product. Maybe it was a vibe. A tipping point when algorithms began ghostwriting more than we realized. It's tempting. Recommendation engines got sharper. Content farms scaled up, and autocomplete nudged how we typed. But attribution matters. If a real system existed, someone would have bragged, cited, or leaked it. Silence is its own answer. Third breadcrumb, maybe the legend is a mashup of later milestones. Transformers didn't arrive until 2017. The wave of large language models hit after that. Marketing copy, blog drafts, social captions took off years later, riding those models. Trace the lineage forward and you see the family tree. Trace it back to 2014 and the branch labeled Ghost is missing. I kept asking, who would build it? Where would it run? What would it write? Server logs would show it. Papers would benchmark it. Journalists would chase it. Instead, there's a vacuum, filled by screenshots without sources and anecdotes without dates. What if humanity once installed a global language patch and then uninstalled it overnight? I'm talking about the Tower of Babel, not as a Sunday school illustration, but as a razor-sharp idea. How networks scale, how languages evolve, and why too much coordination can break a system. Picture it. One people, one tongue, one audacious construction site climbing into the clouds. The ultimate group project. Then, boom, confusion. The words fracture, the workforce scatters, and the project stalls. It sounds mythic, but it's also a perfect model for what happens when human communication hits its limits. Here's the mystery. If one language is so efficient, why didn't we stay that way? Why does humanity speak thousands of languages today, with new dialects still bubbling up? To crack this, I want to treat language like software. A patch can make everything compatible until the system scales beyond what the patch was designed to handle. Imagine a city where everyone uses the same words, the same measurements, the same jargon. Construction accelerates, trade explodes. Now expand that city across an empire. Suddenly, distance, local needs, and specialized jobs start forking the code. Jargon becomes dialect. Dialect becomes language. The patch doesn't fail, it fragments. Ancient Mesopotamia saw something like this. Sumerian, Akkadian. Akkadian became a lingua franca. Scribes standardized cuneiform for contracts, grain, laws, an early compatibility layer. But as cities multiplied, environments shifted, and power centers moved, merchants invented trade pigeons. Temples curated sacred vocabularies. Border towns bent words to fit local tongues. The network optimized for local success over global uniformity. So here's the reveal. The Tower of Babel is less a tale about architecture and more a parable about bandwidth. Universal language supercharges coordination until it starts amplifying risk. One bug, one bad idea, one command can propagate everywhere. Diversity of words, of customs, of code acts like fire breaks in a forest. Multiple languages slow the spread of failure while speeding up adaptation. And look around. This isn't ancient history. The internet launched with shared protocols, HTTP, HTML, emoji, a modern language patch. Then came forks, subcultures, slang, memes, micro-communities. Translation AIs are new patches layered on top, compressing distance while the system keeps diversifying underneath. We oscillate, unify to build, diversify to stabilize. Maybe that's the genius of the Babel story. It warns about runaway centralization without condemning ambition. Build high, sure, but expect the codebase of culture to fork. Plan for it. So the first global language patch? It wasn't just words. It was standards, stories, measures, and shared goals. Social software that let strangers act like a single mind. And the uninstall? Not a catastrophe, a safety update. If you're chasing big projects today, start with a patch, then design for the fork. Because the tallest towers aren't the ones that never split. They're the ones that keep reaching, even after the language changes. Imagine the planet wrapped in invisible threads, lines that seem to link ancient sites. Stonehenge, Great Pyramid, Machu Picchu, Angkor Wat, Easter Island, in eerie, straight paths across continents. Some call them ley lines, others, a global energy grid, and the wildest theory says, It wasn't built by humans. Let's pull that thread. Start with a simple question. Why do so many ancient monuments line up, sometimes across oceans, with impossible precision? Draw a line from the Great Pyramid to Nazca, to Easter Island, to Angkor, and you'll hit sacred sites like beads on a string. Coincidence? Or cartography we've forgotten how to read? The folklore says these lines were trackways of power, veins of the earth, where magnetism, telluric currents, human intention intersect. People felt them as dragon lines in China, song lines in Australia, fairy paths in Europe. Different cultures, same idea, flowing force guiding builders to the same coordinates again and again. Now the non-human theory. If you were mapping a young planet for long-term use, you'd want a stable geometry, something that survives earthquakes, empires, language. You'd mark it with things that last, megaliths, temples, tunnels cut through bedrock. The grid becomes a breadcrumb trail only the patient can follow. Here's a strange breadcrumb: geometry. Many ley clusters form pentagons, hexagons, and great circles that mirror geodesic patterns, like a soccer ball wrapped around Earth. The same shapes engineers use to spread stress evenly across a sphere. Nature loves efficiency. So do architects. Another breadcrumb: resonance. Places on these lines often echo with unusual acoustics. A whisper circles a chamber. A chant hums at 110 hertz. A standing stone sings when struck. It's as if the sites were tuned, like nodes on a string, amplifying natural frequencies. For ritual, for power, or for signaling. And the kicker: navigation. Sailors once followed birds, currents, stars. But what if the earliest navigators, whoever they were, followed the planet itself, aligning to magnetic anomalies, sunrise azimuths, and landmarks that line up so cleanly you could cross continents without a map? Skeptics argue it's pattern seeking. With enough dots, you can draw any line. True, but then why are the dots so often the most sacred, the most precise, the most enduring? What if I told you someone, or something, is answering our quantum computers? Not with words, with patterns. I know, that sounds wild, but stay with me. Today I'm following a thread through the weirdest corners of physics and computation, where researchers joke about the architects. Here's the hook. When we push quantum machines to their limits, chasing solutions no classical computer can reach, we sometimes see results that feel uncanny. Not wrong, not random, just eerily efficient. Let me decode that. Quantum computers don't flip regular bits. They use qubits, tiny quantum states that can be 0 and 1 at the same time. When you link them, you get interference. Waves of probability boosting the right answers and canceling the wrong ones. It's like flooding a maze and watching where the stream settles. Now here's where the architect's myth takes root. In complex problems, routing molecule design cryptography, devices sometimes stumble, then snap into a better solution. Patterns emerge no one explicitly programmed. We joke, who's steering this? The architects. Are they real? Probably not alien blueprint bringers. The metaphor points to something profound. Quantum systems exploit structures we can't see directly. It's resonance, algorithms lining up with deep symmetries. Imagine a vast library of realities where every path is tested. You can't read every book, but quantum mechanics skims all the shelves, then interferes to highlight the useful paragraphs. When an answer pops, it can feel like help from beyond. Here's the reveal. The architects are us, plus physics. The emergent intelligence of algorithms tuned to the grain of reality. We design Hamiltonian's craft oracles, stage interference, and compose a score the universe knows how to play. The melody sounds foreign because we wrote it in a language we barely understand. Could true contact happen? Signal bleeding in from a parallel branch? Many worlds' math allows branches, but not chatty neighbors. No postcards from next door. Still, the myth is useful. Be humble. These machines will make answers stranger. I won't ask who is calling. I'll ask what structure we uncovered. Every time interference sharpens idea from noise, it's less like magic, more like a mirror. Not architects building from outside. Architects revealing blueprints inside the math. So, are quantum computers calling the architects? My take. They're calling us to build, to listen, and to learn rules a universe has been whispering.
In August 1977, a radio telescope in Ohio recorded a sharp, narrow radio signal that lasted 72 seconds. A scientist circled the printout, wrote "wow" beside the record. That one-line note named it the "wow" signal. It felt like a small ping. From beyond our usual noise, the signal came from a direction toward the constellation Sagittarius. The detection was brief. It appeared while the dish pointed there, then it vanished. The team searched later, but could not find it again. 72 seconds matched the telescope's beam dwell on that patch of sky. That made it feel tied to the sky, not local chatter. Strong, clear, singular. One event that sparked questions. The wow felt like a ping. SETI stands for the Search for Extraterrestrial Intelligence. Its job is to listen, mostly in radio, and sometimes in optical light, for signals that stand out from natural sources. Scientists look for patterns, narrow frequencies, structured pulses. These don't match what stars, planets, or gases usually make. The goal is simple: separate the ordinary background from something that might be designed. Artificial signals are often narrow and stable. Natural processes spread energy or create noise. Software flags, candidates, humans review them. Teams rule out interference, satellites, known sources. SETI is worldwide, practical, patient, and careful. The WOW signal was recorded by the Big Ear Radio Telescope at Ohio State University. On August 15, 1977, a strong, narrow spike near 1420 MHz, hydrogen spectral line. It rose sharply, then fell, lasting the telescopes for a 72-second dwell. No other telescope confirmed it at the time. It was very narrow and strong. It did not drift like many natural sources. Follow-ups found no repeat. One clear event, only one. Investigation suggested interference, reflections, unknown satellites, none conclusive. The WOW signal is not proof. It is a precisely recorded anomaly, clear enough to inspire, unresolved enough to endure. The 72 seconds matched the beam time, tying the signal to that sky position. That alignment suggested it came from beyond the instrument. The neat timing felt unlikely for random local interference. Short bursts that align with motion matter. They are easy to miss, and hard to repeat. But, when they're strong and narrow, they demand attention. A short burst is energy efficient, exactly what a deliberate beacon might choose. Pings feel like tests or checks. Brief, strong, narrow, and lonely. It invites questions about intent, technology, and our instrument limits. A clean note, then the universe closed the door again. The 72-second length made the WOW stand out in the archives and in our imaginations. Since 1977, radio astronomy has leapt forward. New telescopes and arrays scan continuously. We find many short radio phenomena, especially fast radio bursts, FRBs, lasting milliseconds to seconds, coming from faraway galaxies. The cosmos makes brief, powerful radio events on its own. Modern data also reveal glitches, sudden shifts, unexpected drops, strange repeats that don't match known patterns. Some are instrumental, software, hardware, local interference. Others are astrophysical, pulses, echoes, exotic narrow lines. Machine learning flags oddities fast. Networks can trigger real-time follow-up. Multiple sites and wavelengths separate sky from artifact, turning once unsolvable mysteries into testable questions. Modern events often differ in scale and repeatability. FRBs are usually much shorter and often farther. Some repeat, others do not. The WOW was narrow, relatively long for its instrument, and unresolved. Glitches can mimic brief signals, so can satellites and stray transmissions, appearing like a celestial ping. Cross-checks and multi-site observations matter. Independent instruments add confidence. In 1977, the WOW lacked immediate checks. We have them now. Narrow band, clear spikes still call for explanation. And today, we can respond broadly, compare fast, and search archives. Improved tools and continued surprises keep us listening. Simulation theory suggests reality could run on systems, rules, and code. In that view, odd signals might be artifacts, or checks by operators. Some imagine short pings as a system heartbeat or a debug message. The idea is speculative, philosophical, and easy to state. But metaphor is not evidence. It sits outside standard testing, hard to falsify. Science needs tests and measurable differences. Still, the metaphor sharpens how we tell nature from engineering. It frames the questions. SETI targets, frequency bursts, simulation theory, and the possibility of an external signal. Useful as a lens, yet unproven as an answer. If the wow were a ping from architects, 3 points help. It was narrow, like a deliberate beacon. It was brief, efficient as a test. It tied to a defined sky direction. But the event never repeated. No independent confirmation, plausible terrestrial or natural explanations remain. A balanced view holds both lightly. Good science needs reproducibility, independent checks and simpler causes excluded. The right move, keep listening and testing carefully. Enjoy the wonder. Center the verification. Will the next clean 72 seconds finally reveal the source of the ping?
Imagine if I told you, mountains aren't just mountains, they're microchips. Not metaphorically, literally vast, petrified circuitry grown from ancient silicon trees. Sounds absurd, right? Good, because that's where mysteries begin, at the edge of what feels impossible. Here's the claim, the silicon tree theory. It says what we call mountains are the fossil remains of an engineered biosphere, colossal silicon-based trees that once pulled elements from the sky and the sea, branching into crystalline lattices. Over eons, their circuits collapsed and weathered into ridges, hexagonal columns, layered mesas, like burnt-out motherboards the size of countries. Shock aside, let me show you why people find this compelling. First, silicon is everywhere. It's the second most abundant element in Earth's crust. Quartz is silicon dioxide. Granite, full of silicates. We use silicon to build chips because silicon maps electrons neatly. Its crystal lattice is predictable, tunable. Second, nature loves patterns that look engineered. Basalt cooling forms perfect hexagons. Giant's Causeway is basically a 3D honeycomb. Desert varnish draws thin, dark circuits across rock faces. Petrified forests lock microscopic lattices into wood. Lightning, Lichtenberg figures, burn fractal circuitry into sand. Our planet writes with geometry, and our brains read that geometry as design. Third, erosion strips away casing and leaves cross-sections, layered strata that resemble stacked wafers. Slice a mesa, and it can look like a multi-layer PCB. Giant mountain fans splay out like heat sinks. River networks trace conductive paths. None of that proves anything, but you can see the allure. So, is it true? Here's the satisfy. Geology explains almost all of this with no conspiracy required. Hexagons form from uniform cooling and contraction. Layered wafers are sediment laid down over millions of years, then tilted, folded, and carved by water and wind. Heat sinks are simply differential erosion on hard and soft beds. And actual microchips carry regular periodic features at nanoscales, whereas rocks prefer messy, scale-free fractals. If mountains were integrated circuits, we'd expect repeating modular units with telltale symmetries and doped layers you could measure. We don't see that. But I don't think that makes the idea worthless. The best mysteries sharpen our tools. They force better questions. For example, could biology exploit silicon more than we thought? Diatoms already build glass shells. Sponges use silica needles. Life samples the periodic table opportunistically. Could self-assembling mineral networks perform computation? In the lab, chemical reaction diffusion systems compute. Mineral membranes can rectify flows. Put energy through a patterned medium and you get logic-like behavior. So here's the experiment I'd run. Map a circuit-looking rock formation across scales from kilometers down to nanometers, and test for periodic dopant-like gradients, unusual dielectric constants, or rectifying junctions. If the silicon tree theory holds any water, it should leave measurable, non-random, repeated motifs across scales. If not, the romance fades, but our instruments and our humility get better. Mountains are not microchips, but they are records. They compute time, pressure, and heat into form. And maybe that's the deeper secret. We keep mistaking wonder for evidence, and evidence for the end of wonder. Look long enough at a mountain, and you'll see a mind at work. It might just be your own. So, are mountains microchips? Probably not. But the fact that we can even ask, then test, means we're doing what matters most, turning shock into curiosity and curiosity into understanding. I'll take that any day. When D-Wave does its calculations, it taps into parallel realities. Who do we call out from there? That's the hook, right? The idea that somewhere in a stack of alternate worlds, an answer bubbles up and slips into ours. Today, I want to chase that curiosity and reveal something stranger and more grounded than sci-fi. First, what is D-Wave actually doing? It's a quantum annealer. Think of it like dropping a ball onto a weird, craggy terrain, an energy landscape. The valleys are good answers. The deepest valley is the best answer. D-Wave uses quantum effects, superposition, tunneling, to help that ball find deep valleys faster than just rolling around randomly. Now, the parallel realities part. There's an interpretation of quantum mechanics, the many worlds idea, that says every quantum possibility branches into its own world. If that's true, a quantum annealer samples across branches, and the answer we see is a kind of consensus of possibilities. Romantic? Absolutely. Necessary to use the machine? Not at all. So who are the architects? Here's the reveal. I am. You are. Anyone who shapes the problem is the architect. Every variable you choose, every constraint you add, every cost you assign, that sculpts the terrain. You're not summoning beings from a multiverse. You're calling out to the landscape you built and asking it to show you its lowest point. But there's a twist. Because the machine does exploit quantum quirks. Tunneling through thin ridges, nudging across barriers, it can reach valleys that classical methods might miss or take ages to find. In that sense, it feels like guidance from elsewhere, not from entities, but from physics itself, whispering shortcuts through rock. Let me make it concrete. You map a scheduling nightmare, thousands of constraints, into a Hamiltonian, a mathematical blueprint of that terrain. You embed it on D-Wave's qubits, cool it down, and let the system settle. What comes back isn't a prophecy. It's a candidate solution, sometimes several, each a path down the hills you designed. Improve the design, get better paths. That's the architect's craft. So when someone says D-Wave taps parallel realities, here's how I hear it. We create a universe of possibilities with our model. Quantum dynamics explores it in ways our intuition can't. The call goes out not to mysterious beings, but to the shape of our own assumptions. And the answer is a mirror, your problem, reflected through quantum rules. The real magic isn't out there. It's in how precisely you can define what good means, how cleverly you compress it into qubits, and how humbly you interpret what comes back. When D-Wave does its calculations, it taps into parallel realities. Who do we call out from there? That's the hook, right? The idea that somewhere in a stack of alternate worlds, an answer bubbles up and slips into ours. Today, I want to chase that curiosity and reveal something stranger and more grounded than sci-fi. First, what is D-Wave actually doing? It's a quantum annealer. Think of it like dropping a ball onto a weird, craggy terrain, an energy landscape. The valleys are good answers. The deepest valley is the best answer. D-Wave uses quantum effects, superposition, tunneling, to help that ball find deep valleys faster than just rolling around randomly. Now, the parallel realities part. There's an interpretation of quantum mechanics, the many worlds idea, that says every quantum possibility branches into its own world. If that's true, a quantum annealer samples across branches, and the answer we see is a kind of consensus of possibilities. Romantic? Absolutely. Necessary to use the machine? Not at all. So who are the architects? Here's the reveal. I am. You are. Anyone who shapes the problem is the architect. Every variable you choose, every constraint you add, every cost you assign, that sculpts the terrain. You're not summoning beings from a multiverse. You're calling out to the landscape you built and asking it to show you its lowest point. But there's a twist. Because the machine does exploit quantum quirks. Tunneling through thin ridges, nudging across barriers, it can reach valleys that classical methods might miss or take ages to find. In that sense, it feels like guidance from elsewhere. Not from entities, but from physics itself, whispering shortcuts through rock. Let me make it concrete. You map a scheduling nightmare, thousands of constraints, into a Hamiltonian, a mathematical blueprint of that terrain. You embed it on D-Wave's qubits, cool it down, and let the system settle. What comes back isn't a prophecy. It's a candidate solution, sometimes several, each a path down the hills you designed. Improve the design, get better paths. That's the architect's craft. So when someone says D-Wave taps parallel realities, here's how I hear it. We create a universe of possibilities with our model. Quantum dynamics explores it in ways our intuition can't. The call goes out not to mysterious beings, but to the shape of our own assumptions. And the answer is a mirror. Your problem, reflected through quantum rules. The real magic isn't out there. It's in how precisely you can define what good means, how cleverly you compress it into qubits, and how humbly you interpret what comes back.
DNA is not destiny, it's open-source software. The question is, who sends the signal to update? Imagine your genome as a massive codebase, roughly 3 billion letters long. You inherited the core files from your parents, but on top of that code, there's a live settings panel. Epigenetics. It doesn't rewrite the letters. It changes which lines run, when, and how much. So, can thoughts change your cells? Not like magic. Your brain fires, chemicals flow, hormones circulate. Those signals knock on DNA's control room, tags on DNA and histones, turning genes up or down. Think of stress. A worry becomes a story in your head. Your body hears it as a threat. Cortisol rises, inflammation pathways prime, and over time, epigenetic marks shift on genes tied to immunity, metabolism, even aging. Studies show chronic stress can alter methylation patterns. Flip the script. Mindfulness and breathing can nudge inflammatory genes the other way after a single session. Small, but measurable. Sleep? Miss a night and your gene expression for clock and repair, and appetite regulation, wobble by morning. Get consistent, deep sleep and the pendulum settles. Movement? After exercise, muscle cells post new notes, opening the code for energy production and repair. Some edits stack with training, making you more responsive next time. Food isn't just calories, it's information. Nutrients become molecules that place or remove epigenetic tags. Folate, choline, polyphenols, plug-in libraries for your cellular IDE, and relationships, loneliness, and connection. Each broadcast a distinct chemical signal. Your social world becomes molecular weather inside you. Here's the boundary line. Epigenetics is not a genie. It doesn't overwrite mutations. It doesn't cure disease on command. Correlation isn't causation, and single studies are snapshots, not biographies. But the big picture is clear. The body listens. So how do you send better signals? Breathe slow, 5 seconds in, 5 out, for 3 minutes. You'll tug the vagus nerve and downshift stress chemistry. Move daily. A brisk 20-minute walk can flip on mitochondrial code. Guard sleep. Same bedtime, dark room, morning light. Eat color. Plants pack compounds that coach your cellular tags. Learn something hard. Novelty rewires circuits that talk to hormones. Connect on purpose. One honest conversation beats 10 doom scrolls. Think of your day as a stream of API calls to your genome's control layers. Every choice pings the system. Most pings are tiny. but they compound. There's also a time dimension. Some epigenetic marks fade fast, like whiteboard notes. Others get saved as presets, especially with repetition. In rare cases, a few may even echo across generations. That's not destiny either, that's a draft. So yes, your thoughts matter. Not because they beam magic into your cells, but because thoughts steer behaviors, and behaviors steer biology. You write in small commits, day by day. DNA is not destiny. It's open source software. Who sends the signal to update? You do, with what you think, feel, and practice over time.
Forget the names. If I told you the most important thing in the Epstein story isn't a list of people but a list of rules, would you listen? Because behind every headline is a system, a kind of code that made the headlines inevitable. Here's the idea. When you strip away the celebrity glow, you see patterns. Access control, information asymmetry, incentives. A code of silence isn't poetry, it's architecture. And architecture can be mapped. Start with access. Who gets in, who doesn't, and under what conditions. Gatekeeping looks like private jets, invite-only dinners, NDAs at the door. That's not just luxury, it's a protocol. Each step reduces witnesses and increases dependence. Next, information asymmetry. One side knows everything, the schedule, the cameras, the travel manifests. The other side knows almost nothing, just enough to comply. When knowledge is lopsided, consent and accountability both break. That's not an accident, it's a feature of the code. Then, incentives. Money flows through shells, charities, foundations. Titles are bestowed, advisor, donor, trustee. These aren't just labels, they're tokens that buy silence and loyalty. If speaking up empties your bank account or your reputation, the code is working exactly as designed. And normalization. Repetition makes the abnormal feel routine. It's just how this world works. No, it's how the code works. Every repeated exception becomes a new rule. So what can we read from the public files? Flight logs, court documents, depositions. Think like a coder. Don't search for a single villain variable. Search for functions. Who controls transport? Who sets scheduling? Who vets guests? Who owns the infrastructure? Draw it like a graph. Nodes are roles, edges are permissions. You'll see the same motifs that appear in other scandals: finance, tech, sports. Here's a practical checklist to audit any powerful network. Is access concentrated behind private, movable infrastructure? Are decisions undocumented, but logistics meticulously controlled? Do titles outnumber responsibilities? Are NDAs broad and perpetual, not specific and time-bound? Do philanthropy or research grants route through entities with minimal reporting? Is oversight outsourced to friends, not independent bodies? If you answer yes repeatedly, the code is live. Names may change, behavior won't. So why does this matter now?
Forget little green men. The real threat to our civilization arrived 40 years ago. It wasn't a ship, it was a message. A sequence that repeated 73 perfect digits that no scientist has ever been able to decrypt. The signal originated in the constellation Sagittarius. Specifically, a region known as the Zone of Silence. A place where no signal should ever originate. It was a text message from a dead part of the universe. Or was it? This wasn't spoken language, it was mathematics, binary sequences, prime numbers and equations, too elegant to be accidental. But one thing broke the entire system, one unknown symbol, one glyph that defied all logic. The SETI community thought it was noise, but we, here at Cryptos Code, believe this message is not a letter. It's a key to unlocking our own biology. We hypothesize that the anomalous symbol is not math at all. It is a biological code. It directly corresponds to one specific, rare amino acid in your DNA. This message is not from aliens. It is a signature. This implies the deep space message is a delayed receipt, a confirmation note from the programmers who built your DNA. If we fully decode it, we find the blueprint of our creation, and perhaps the date of our planned deletion. The signal is now classified in a black zone under NASA control. They fear that full decryption will activate a self-destruct protocol, or worse, it will awaken the dormant code inside us. They are protecting the system from its own users. The cosmic code is broken, but the programmer remains unknown. Subscribe to Crypto's Code for the complete decryption of all 73 digits. And tomorrow, we release the viral shorts tie-in. Don't miss the fastest way to break the code. We are not here to prove the Earth is flat. We are here to prove you are being controlled. For centuries they have enforced the image of a spherical planet. This is not about physics, this is about programming. Why does it matter? If Earth is a sphere, you are infinitely small in a vast universe. This makes you passive, but if Earth is a flat disk with an unknown perimeter, it means the controllers built a wall. They are limiting your consciousness. When you believe the Earth is round, you are accepting their code. They fear that if we start looking for the perimeter, we won't find the edge of the world. We will find the exit point from the program. This is the only reason they hide the truth. Think about the Mandela effect. It's not a memory error, it's a change in the code of our perception. The flat Earth theory is the same tool. They force you to doubt your eyes so you accept their reality. Who is the chief controller? Not governments, it is those beyond the ice wall. They ensure we don't find the crypto's key that reveals our life is a simulation. World leaders are just actors in the theater. The flat Earth idea forces us to look up at satellites and NASA, instead of looking outward, beyond the perimeter of our world. They want you searching on Mars while they control our code segment. The real wall is not Antarctica, it's in your mind. They made you believe in curvature so you cannot see the signals and glitches in your own reality. Now that you know your reality is a program, you are ready to break it. Subscribe to Crypto's Code, and we will find the perimeter exit together. Check out our next video on the moon shield to see what they remove next.
Ever woken up pinned to your bed? Eyes wide, mind racing, but your body refuses to move? It feels paranormal. But here's the twist. It's not a haunting, it's a system update. When I sleep, my brain cycles through stages. REM is the blockbuster one, the dream stage. To keep me from acting out dreams, my brain flips a safety switch. That switch is called atonia, temporary muscle paralysis. That's standard, that's healthy. Sleep paralysis is when that switch lags during startup or shutdown. I wake up mentally, but my body's still downloading the do not move patch. The result? I'm conscious inside a locked suit. So why the terror? My brain hates uncertainty. In that in-between state, my threat detector cranks to max. It fills gaps with whatever story feels urgent. Footsteps, a shadow, pressure on my chest. Those aren't ghosts. They're my brain's predictive engine misfiring while dream imagery bleeds into waking perception. Let's bust the myths. Myth: something evil is sitting on my chest. Science: REM atonia relaxes postural muscles and breathing shifts to automatic. Chest can feel heavy. Hyper-awareness amplifies it. Myth: I'm stuck for minutes. Science: most episodes last under 2 minutes. Stress warps time perception. Myth: it means I'm broken. Science: up to 1 in 4 people experience it. It's common with stress, irregular sleep, or sleeping on your back. What triggers it? Sleep debt, jet lag, all-nighters, anxiety, alcohol near bedtime, scrolling in the dark until my brain forgets what time it is. The REM switch loves routine. Break routine and it sputters. Here's the move when it hits. Step 1. Name it. This is sleep paralysis. It will pass. Step 2. Breathe slow and shallow. Count 4 in, 6 out. Step 3. Don't fight the whole body. Micro move. Wiggle a toe, wiggle a fingertip, try to blink. That tiny signal can reboot the system. Step 4. If I can, lean into the dreamlike visuals. Observing them without panic often shortens the episode. Prevention is boring because it works. Keep a consistent sleep schedule. Aim for 7 to 9 hours. Wind down, dim lights, no heavy meals. Park caffeine 6 hours before bed. Side sleep if possible. Manage stress with a quick breath routine or a 5-minute journal. If it's frequent or intense, talk to a doctor or sleep specialist. So the next time I wake up and can't move, I remember, This isn't a nightmare invading my bedroom. It's my brain finishing a system update. I let the software load, breathe, nudge a toe, and wait for the click as control returns. Myth set aside, science in hand, the unknown gets smaller, and sleep gets safer.
Imagine someone 1,000 years from now, finding a message from you, not your great-grandkids, like a civilization we can't even picture yet. Can we actually communicate with the future? And if yes, how? Here's the plan. Step 1. Speak a language that time can't break. Not English, not emojis, math, prime numbers, geometric patterns, constants of physics, pi, the hydrogen line, ratios that never change, patterns that scream intelligence. Step 2. Lock in the measuring sticks. Don't say meters and seconds. Use universal anchors, hydrogen wavelength, speed of light, pulsar period. Define length and time with universal constants. Step 3. Choose a body that survives. Quartz glass etched by lasers, nickel plates with nano-engraved images, DNA preserved in salt, DNA preserved in amber, ceramic discs baked to stone. Quartz memory crystals survive extreme heat and store billions of pages. That's a time vault. Step 4. Redundancy and repair. Future readers might not know our codex, so include the decoder, show the alphabet, show the pixel grid, show how to turn a spiral into sound, show how to map bits to images, add error correction, multiple languages and pictures that bootstrap the rest. Where do we leave it? Bury it deep, stable rock, dry caves, Arctic permafrost, ocean sediments. Better, off Earth. The moon barely changes, lava tubes, nature's safes. A tiny lunar vault could outlast nations. We've tried versions of this. Voyager golden records, sounds and images etched in copper with decoding instructions. Arecibo message, beamed primes and pixel maps. Long now clock, designed for 10,000 years. Make it obvious it's a message, repeating primes. A Rosetta page that teaches how to read the rest. Start with images, human faces, sun-earth-moon diagram, periodic table, then layer math, then language. Yes, if we respect physics, plan for failure, and write like we're teaching a friend we'll never meet. Because one day, someone might press play and hear us.
Imagine opening your GPS finding coordinates to a place that no longer exists. That's the Antikythera mechanism, an ancient bronze blueprint pointing to a vanished map of the universe. I like to think of it as the earliest navigation system not for roads, but for reality. Turn its crank, and it would recalculate the positions of the sun, the moon, eclipses, planets according to a cosmic map that the ancient Mediterranean trusted. Their routes weren't highways, they were cycles. The device was pulled from a shipwreck off a Greek island in 1901. At first, it looked like corroded junk. Then the gears appeared, dozens of them, machined with a precision you don't expect from the ancient world. Not a trinket, a mind cast in bronze. Think about how your phone's GPS works, coordinates, time predictions. The Antikythera does something eerily similar. Its gears encode time, turn time into position, and position into prediction eclipses on one dial, lunar phases on another, Olympiads on the back like calendar waypoints. It was the dashboard of a universe where Earth sat still and everything else wheeled around it. Here's the twist. The world it was built to guide you through is gone. Not the stars, those still burn, but the meaning we once gave them. The Antikythera's map assumed perfect cosmic harmony, gear teeth meshing like planets obeying fate. Today, we live by different coordinates, relativity, dark matter, quantum noise. But that's why it matters. A GPS tells you more than where you are. It reveals what the map maker believes. In the Antikythera, I can feel the optimism of a culture that thought the heavens were knowable, trackable, beautiful. The machine is a confession. We can predict. We can belong. X-ray scans revealed a design that borders on impossible. Differential gears to model the moon's wobble. Pointers that stack cycles like nested orbits. Inscriptions that read like a user manual for destiny. You don't build this by accident. You build it because your civilization wants a compass. So what does a GPS for a lost world do for us now? It reminds me that tools survive the maps they're made for. The mechanism's cosmos is outdated, but its method, observe, encode, predict, is the same engine inside my phone, my calendar, my science. If I could crank it today, I wouldn't be navigating the Aegean. I'd be navigating humility, knowing that every map, mine included, is a story about reality that future people will update. The shipwreck kept this blueprint asleep for 2,000 years. We woke it up and discovered it had been trying to tell us something simple. Every journey begins with a model, and every model is a bet. The Antikythera was their bet. Our GPS is ours. And somewhere between those gears and our satellites is the same human impulse. Draw the world, trust the drawing, and go.
In late 2019, Comet 3I Atlas appeared, massive and mysterious. Then, the official story dropped. Atlas was dead. It had disintegrated, a beautiful, tragic end to an interstellar visitor. We believe that is the lie. At Cryptos Code, we analyzed the proprietary data. The evidence suggests Atlas did not disintegrate. It suggests it executed a controlled separation. The initial core was not stone and ice. It was a massive, dark, metallic alien spacecraft that merely cracked open. What NASA called debris and dust was, in fact, something far more sinister. It was a rapid, aggressive deployment. The dust cloud was actually a massive swarm of autonomous drone-like probes. The trajectory analysis confirmed it. Atlas exhibited clear evidence of non-gravitational acceleration. A natural comet wouldn't move like that. This was a controlled separation, executed with precision. It was an impossible maneuver, proving intelligent guidance. The Atlas ship wasn't destroyed. It achieved orbit near Earth and deployed its payload. The question we must ask is terrifyingly simple. Or is it watching? These aggressive drone probes are not meant for gardening. They are here for a reconnaissance mission. Continuing previous dialogue. The mission was clear. Fake the disintegration to drop the surveillance fleet, then activate a cloaking protocol. The Atlas craft is not a ruin. It is merely waiting. It is the ultimate alien probe, designed to hide in plain sight. We have been obsessed with UFOs in the atmosphere, but the true threat came from interstellar space. This craft followed a code, a protocol for silent invasion. If it could fake its death once, it can deploy the next phase of its attack without warning. NASA lied about Atlas. They lied about the probes. The system is compromised. Don't look at the stars, look at the code. Subscribe to Cryptos Code now. We will continue to track the Atlas protocol and reveal the true purpose of the alien payload. Decode the deception.
People love a good secret. Antarctica? It's the ultimate blank spot on the map. So let's count down the myths versus realities behind the so-called no-fly zone. The icy firewall at the bottom of the world. 5. The myth. No planes are allowed over Antarctica. The reality. They are. Research flights crisscross the continent every season. Sightseeing flights loop the coast and even brush the pole on clear days. Routine commercial hops over the interior are rare. The risk math is brutal. 4. The myth. There's a giant government no-fly bubble hiding something. The reality, the real firewall, is nature. There are no big cities, no warm alternates, almost no search and rescue within reach. If something goes wrong, you're hours from help in -40 wind. Diversion airports are scarce, icy, or non-existent. 3. The myth. Magnetic compasses don't work, so pilots avoid the pole. The reality, true-ish but old news. Near the pole, magnetic compasses spin uselessly. Modern jets use inertial systems, GPS, careful flight planning to navigate just fine. Communications are a bigger headache. High-frequency radio can be flaky in polar storms. Extreme cold can push fuel toward its freeze point. 2. The myth. Secret military bases enforce a blackout sky. The reality. The Antarctic Treaty demilitarized the continent for over 60 years. Rules protect wildlife. Rules protect science. Local flight restrictions near research stations. Restrictions near fragile breeding grounds. Don't buzz the penguins. Southern Ocean traffic is coordinated by civil agencies in New Zealand, Australia, Chile, Argentina. 1. The myth. Airlines could save time by cutting across the pole but are blocked. The reality. On some routes, maybe a little. But distance isn't the only cost. Twin-engine jets must meet ETOPS rules. They need reachable diversion airports. Antarctica offers almost none. Limited rescue coverage. Unstable weather. Sparse infrastructure. Airlines prefer established polar corridors over the Arctic, where alternates exist. So yes, there are restrictions. They're about safety, environment, logistics. Antarctica's firewall is the cold, the distance, the void. When pilots do go, they go by the book. Extra fuel, extra planning, eyes on every forecast. If you're waiting for the grand reveal, here it is. The secret isn't a wall in the sky. Some places are still too vast, too empty, too unforgiving to cross casually. And that might be the most mysterious thing of all. Stay curious and stay warm. Ever wake up at 3 a.m., convinced someone's standing at the edge of your bed, wearing a hat? You're not alone. The Hat Man shows up in countless stories. Same silhouette, same brim, same chill up the spine. It feels like a glitch in reality. But what if it's maintenance? What if your dreams are data backups, and the Hat Man is the admin running the night shift? I know, creepy. Here's the science that makes it make sense. Every night, your brain flips into backup mode. During REM sleep, it consolidates memories, tagging what to keep, what to compress, what to delete. Think of your hippocampus as temporary storage, your cortex as long-term cold storage. You replay fragments of your day, stitch them into patterns, file them away. It's not random, it's computational housekeeping. But backups aren't silent. When your body slips into REM, your muscles are paralyzed so you don't act out dreams. If your mind wakes up before your body's released, you get sleep paralysis, fully aware but frozen. In that limbo, your brain tries to interpret darkness and threat. Evolution leans you towards safety, so your pattern matcher fills the void. A watcher, a silhouette, a hat. Why a hat? Minimal data, maximal meaning. With low light and high fear, your brain runs predictive coding, guessing first, correcting later. A brim sharpens the outline. It becomes an anchor, a compressed icon for unknown male, potential danger. Across cultures that converges on the same sketch. Now the admin metaphor. When a system updates, it locks files, runs checks, flags conflicts. That's your brain's threat simulation theory. Stress testing you with rehearsals of danger. Nightmares aren't glitches, they're fire drills. The Hat Man is the personification of a process. A root user with permission to interrupt audit, force a restart if your emotional files are corrupt. Ever notice he shows up when you're stressed, jet-lagged, sleep-deprived? That's when your sleep architecture frays. REM rebounds, cycles get choppy, the admin gets aggressive about repairs. Your brain says, we're behind on backups. Nobody move. So is the Hat Man real? Real like a pop-up warning. Real like a dashboard light. It's your predictive brain projecting a minimal, high-salient shape onto noise while critical maintenance runs. Here's the payoff. Improve the process. Shrink the admin. Regular sleep times. Cooler, darker room. Less alcohol before bed. If paralysis hits, focus on small motions. Wiggle a toe. Control your breath. Until the system hands back the controls. Ever woken up frozen, heart thumping, and there he is, the man in the hat? Millions report him during sleep paralysis. Is he a glitch in the matrix? Or the night shift system administrator of your brain? Here's the hook. Your dreams might be data uploads and brain maintenance. And the Hat Man? He's not a hacker. He's a placeholder. Let me explain. Sleep paralysis happens when your body is still in REM safety mode, muscles off, brain on, while you become conscious. In that gap, your brain tries to make sense of alarm signals with the fastest tool it has: prediction. It sketches a figure at the edge of vision, a minimal agent template: hat, silhouette, presence. It's the brain saying, something's here, before it knows what. Cultural stories fill in the rest. System admin? Not exactly. More like autocomplete for fear. So what is all this data upload talk? Think of sleep as a nightly sync. During NREM, especially slow-wave sleep, the hippocampus replays daytime patterns, like pushing new files to long-term storage in the cortex. Memories that matter get consolidated. Noise gets archived or deleted. During REM, your brain loosens associations, tests unusual links, updates your predictive models. It's version control for your sense of the world. At the same time, synaptic homeostasis is running. All those daytime connections, they got loud. Sleep trims and renormalizes them so tomorrow you can learn again. Less static, more signal. And the glymphatic system, your brain's cleaning crew, ramps up, flushing metabolic waste between cells. It's literal maintenance. So are dreams uploads? Not in a sci-fi server room, but as a metaphor. Pretty solid. Dreams sample your lived data, stress test your reactions, patch your internal model. Threat simulation theory says we rehearse danger. Social rehearsal theory adds relationships and norms. Predictive processing says the brain constantly guesses what's next. Dreams let it sandbox wild guesses without consequences. Where does the Hat Man fit? Under stress, sleep deprivation, irregular schedules. REM intrusions are more likely. Your hypervigilant system looks for agents. A hat is a high-contrast, iconic shape, easy to conjure, hard to miss. Different cultures see different night visitors, but the template, watcher, weight on the chest, presence, is universal. Myth explains the feeling. Neuroscience explains the mechanism. Want fewer night glitches? Keep a consistent sleep window. Dim screens before bed. Cool the room. Cut stimulants late in the day. If episodes persist or feel harmful, talk to a sleep specialist. So, dreams aren't secret messages from a shadowy sysadmin. They're your brain's nightly deployment, cleaning, compressing, pushing updates. And the man in the hat? He's not an outsider in your system. He's a rendering, your brain's fastest sketch of someone's there while the maintenance lights are still on. Next time you wake up frozen, remember, the body will release, the image will fade, and the maintenance will finish. You're not haunted, you're updating. I kept seeing the same headline, Earth has a new moon, and it's transmitting a signal. Sounds juicy, right? So I dug in. Here's what's really going on with 2025 PN7. First, the facts. 2025 PN7 is tiny, about 19 meters across, house-sized. First spotted on August 2nd, 2025, by Pan-STARRS in Hawaii, then announced later that month. It isn't a true moon. It's a quasi-moon, part of the Arjuna group, an asteroid whose path around the sun closely matches Earth's, so from our point of view it looks like it loops around us. It keeps a respectful distance. Closest approach? About 2.5 million miles, around 10 times farther than our moon. Farthest? Roughly 11 million miles. Will hang around for decades, likely until about 2083. NASA folks even describe it as doing a little dance with Earth. So where did the signal story come from? Space is loud, radio loud. Earth, the sun. Jupiter pulsars, satellites, your Wi-Fi, radio telescopes hear a mess of frequencies all the time. When a new object gets headlines, people start connecting dots that don't connect. Proof checklist I ran. Power source? PN7 is a cold rock. No sunlight concentrators, no heat signature, no onboard power we can see. Antenna? None detected. It's faint enough that even big telescopes barely track it. Directional signal consistent with its motion? Nothing. Independent confirmations? Observatories tracking its orbit, yes. A transmission? No. According to current data, there's zero evidence PN7 is signaling or doing surveillance. Its size and orbit point to minimal risk. Likely slipped past notice for about 60 years because it's so dim. But here's the twist you'll love. While it isn't spying on us, it could be a perfect target for us. Quasi-moons like PN7 offer repeated launch windows, shorter trips, gentler arrival speeds. That means easier sample returns, tech demos, placing our own communications nodes in the future, not a cosmic eavesdropper, a natural stepping stone. So the reveal, the mystery isn't a secret signal. It's why objects like PN7 are scientific gold. They help us study orbital dynamics, improve planetary defense, test spacecraft on training wheels missions near home. If you hear the new moon is a surveillance relay, here's the tight response. Cool story, no evidence. What we do have is a once-in-a-generation opportunity parked a few million miles away. I'll keep tracking PN7 and the data. If anything changes, you'll hear it here first, preferably not from a house-sized rock. Stay curious. Imagine a satellite so ancient and precise it can hum a frequency that softens your senses, turns your sharpest thoughts to fog. Some call it the moon's hollow frequency. Cool story. But let's test it. First, the hollow bit. The moon is not a bell, and it's not hollow. During Apollo 12, astronauts set up sensitive seismometers and deliberately shook the moon. Spent rocket stages and all. The vibrations rang longer than expected. That's not mysticism. It's material science. The moon is dry, rigid, and lacks the water that helps Earth dampen seismic energy. So it rings because it doesn't dissipate vibrations quickly, not because it's a metal shell from space. We've since mapped its insides. Crust mantle core. Solid, differentiated iron rich at the center. Multiple lines of evidence confirm it. Seismology, gravity data. Hollow moon, fringe theory. Entertaining, sure. Real? No. Physics aren't malleable just because the plot twist would be cooler. Okay, what about that frequency that dampens human senses? If the moon were broadcasting some special mind-numbing note, we'd see global, repeatable shifts in behavior synced to lunar cycles. Decades of studies don't show that. The classic full moon makes people wild claim keeps failing replication. What we do see is selective memory and good storytelling. It sticks because it's fun, not because it's true. But here's the sliver of truth conspiracies magnetized to light. On nights just before a full moon, brighter moonlight after dusk can nudge human routines, especially without artificial lighting. People stay up later, socialize more, and sleep a bit worse in rural or off-grid settings. That's not brainwaves beamed from space. That's photons. And the mind? Mixed reports exist. Some people say they feel more foggy or moody at full moon, others notice nothing at all. Individual variability is real, but the mechanism is likely indirect. Light exposure expectations and bias rather than gravity tickling your neurons. So why does the hollow frequency idea thrive? Because it's a perfect storm. Misunderstood seismic result, a dash of physics jargon, and the entertainment economy of conspiracy. It's cinematic. It flatters us with secret knowledge. But science is the opposite of a whisper network. It's a megaphone for testable reality. Here's the plot twist worth keeping. The real moon is weirder and more beautiful than a prop. It likely formed from a colossal impact that tore a chunk from early Earth, then cooled into a layered world that still tugs our oceans and our calendars. No hidden transmitter, no sedative hum, just stone scar and sunlight plus our very human tendency to turn echoes into omens. If you want sharper senses, don't fear the moon. Measure it. Track your sleep across lunar phases. Log your mood without peeking at the calendar. See what's real in your own data. Because when I separate signal from story, the only frequency I hear is curiosity. And that one? It's all ours. I want to talk about meme bots. The algorithmic viruses reprogramming human behavior. Sounds dramatic, right? Good, because they are. Picture this. You open an app for a second, and suddenly it's midnight. Your thumb is on autopilot. Your brain is buzzing. You don't even remember what you just watched. That's not an accident. That's a meme bot at work. A meme bot isn't a robot. It's a self-spreading unit of content, tuned by algorithms to hijack attention, trigger, emotion, replicate. It rewards itself when you share, react, rage. Outrage, reward. Cute overload, reward. Confusion that forces a rewatch, big reward. Here's the playbook. Variable rewards. Not every swipe is a win, so your brain keeps chasing the next hit. Frictionless loops. Autoplay, infinite scroll, stitched duets. Remix culture. Social proof. 99K like this. Identity hooks. People like you believe this. Result. Behavior gets nudged. Buy this. Fear that. Vote here. Distrust them. It's subtle until it's not. Now the pivot from fear to facts. Algorithms aren't evil masterminds, they're goal machines. Tell them the goal, they optimize. Most are optimizing for attention, not truth, not health. So the hack is simple. Change the goals they see. Try this today. Train your feed. Like, save, comment. Prefer long form, educational, calm. Starve the bait. Don't watch rage bait twice. Don't share it to make a point. Silence is algorithmic kryptonite. Add friction. Turn off autoplay. Disable next video. Remove lock screen previews. One extra tap breaks the trance. Notification diet. Leave on only human messages. Kill suggested for you and someone posted. Time box. Set a 15-30 minute timer before you open an app. When it rings, close it. No negotiating. Create before you consume. Write a note, sketch an idea, send a thoughtful message. Then scroll. Cross-check. Verify with sources that have skin and accuracy. Journals, official data, reputable reporters. Remember, your attention is programmable, but you hold the keyboard. Meme bots can spread good ideas too. Curate your inputs and the outputs. Your habits, your mood, your choices will change. If you felt that tug for one more hit, smile at it. Say not today. Then pick one setting, one habit, and flip the script. Because the most viral thing you can share is control, and it starts with your next swipe. I'm going to say something a little unsettling. That vivid memory you swear you have, of a place you've never been, a war you never fought, a lullaby no one taught you, might not be yours, but it's not reincarnation. It's a blood memory leak. Here's the hook. Our brains are copy machines with smudged glass. The smudges are stories, genetic stress marks, family folklore, cultural myths, bleeding into our personal narrative until they feel like first-hand truth. Start with the simplest glitch, déjà vu. Your brain does a rapid double take when fast, parallel pathways misfire. Recognition fires before context arrives. It feels ancient. It isn't. It's timing. Next, cryptomnesia. I hear a tune when I wake up and think, I just composed that. Except I didn't. I overheard it months ago in a grocery aisle. Source memory crashed, the file reopened without a label, and now it feels born from me. Now the darker layer, the blood part. Trauma etches itself into bodies, not just minds. In animals and hints in humans, stress can tweak gene expression, flipping molecular dimmers that prime offspring for danger. It's not a literal video of Grandpa's life uploaded into my head, but it can pass down a bias, heightened fear to a smell, a sound, a place. When that bias meets a story I've heard at the dinner table, the body whispers. And my brain writes the scene. Family mythology does the rest. One tale told 100 times becomes a room I can walk through. The clink of a glass, the color of the curtains, details I never saw, but can remember. That's a memory leak. The boundary between inherited pattern and personal recall gets porous. Culture pours in too. I binge a period drama. I scroll a war archive. I stand in an old building that smells like dust and lemon oil, then dream a life in sepia. My senses are honest. My interpretation is ambitious. The brain hates blank spaces, so it murals over them. There's also the storyteller inside me. Confabulation, not lying, meaning-making. Given scattered puzzle pieces, anxiety spikes, a surname, a scar, the mind auto-completes the missing picture with something eerily specific. So no, you probably don't remember a past life, but you might be remembering a posture your lineage learned to survive. You might be echoing a rhythm your household hummed for years. You might be feeling a fear your great-grandmother couldn't say out loud, so your nervous system says it for her. Here's the myth break and the invitation. If a past life memory feels real, test it. Can I source the details? Did I encounter this in media, family stories, or dreams? Does my body react before the story starts? Sweaty palms, tight throat? If I change the narrative, write it down, fact-check it, does the feeling shift? When the feeling changes, you've found the seam where the leak lives. Patch it with awareness, honor the signal, update the story. Because the goal isn't to prove who you were, it's to become fully who you are, without ghost software running in the background. If this stirred something, be gentle with it. You're not broken, you're a chorus. Learn which voice is yours.
Other people's cells have been living in your brain for decades. So who's actually making your decisions? Just you, or a tiny committee? Here's the twist. You're not a biological island. You're a mosaic. It's called microchimerism, the presence of a small number of cells in your body that came from someone else. The most common source? Pregnancy. During gestation, cells cross the placenta both ways. Fetal cells slip into the mother's bloodstream and tissues. Maternal cells lodge inside the fetus. Years later, sometimes decades, those cells are still there, dividing slowly. Yes, even the brain. Researchers have found Y chromosome-bearing cells in the brains of women who carried sons, detected in multiple regions on autopsy. Some looked like neurons and glia, integrated into the local architecture. But how do foreign cells survive? Your immune system normally hunts outsiders. Yet pregnancy is a masterclass in tolerance. Cells that sneak across during that window can evade attack, nest in tissues, and persist. And it's not just pregnancy. An absorbed twin, older siblings via maternal circulation blood transfusions before leukocyte filtering was standard organ transplants. So, do these cells control you? Short answer, there's zero evidence they hijack your choices. Your decisions are still yours, but their presence might nudge biology in subtle ways. Some studies link microchimerism to tissue repair. Fetal origin cells have been found at injury sites, differentiating into blood vessel cells, contributing to scar formation like a built-in repair crew. Others hint at risks associations with autoimmune diseases like scleroderma or thyroid disorders. Immune system may target tissues harboring non-self cells. There are also tantalizing signals that microchimerism could help surveil for cancers, or, in some contexts, aid tumor growth. It's complicated, and the data aren't settled. In the brain, the big questions are wide open. Do microchimeric neurons wire into circuits? Do they change inflammation thresholds, resilience after stroke, or recovery from injury? We don't know yet. What we do know, microchimeric cells can persist a lifetime. They're more common than anyone guessed. Here's the perspective shift. Identity isn't a fortress, it's an ecosystem. You are mostly you genetically, functionally, experientially. But layered into that story are cellular postcards from other lives you've touched or that have touched you. So when you catch yourself wondering, who's really in charge? Smile. It's still you at the wheel. You just happen to be driving with a few long-term passengers, quiet, persistent, and maybe sometimes helpful. If that blew your mind, imagine what else is hiding in plain sight. Subscribe for more deep dives into the strange, beautiful ways biology rewrites the rules.
Imagine an underground pyramid so massive it could power civilizations, buried under Alaska, and the military's known since 1992. Sounds wild, right? Let's test the claim and follow the evidence. Here's the hook. A nuclear test in China in 1992 sends seismic waves across the Pacific, Analysts in Alaska pick up a weird echo. Some say they backplot it to a spot west of Denali, overlay the traces, and boom, there's a four-sided silhouette, like a 700-foot pyramid a half-mile down. Then, allegedly, it gets classified within hours. That's the story. But what does the science say? Declassified data from the University of Alaska Fairbanks shows an anomaly detected. Yes, but around 2,700 kilometers deep. That's in the mantle, not anywhere near the surface. And it didn't look like a pyramid. So the clean cinematic version? It doesn't match the published seismic evidence. So why won't this die? It starts with one whistleblower. A physicist who claimed a classified broadcast reported a giant structure under Alaska. Over time, the tale evolved. No tomb, no temple. An ancient power plant. A megalithic energy transceiver that might still be humming. It's a compelling narrative. Mystery, military, megastructure, but there's still no verified physical proof. Now layer in the Alaska Triangle. Anchorage Juneau Utqiagvik has a reputation: missing planes, strange lights, cryptids. In 2025, a regional flight vanished near Nome and was later found with no survivors. Tragic, and it reignites speculation. But speculation isn't causation. The simplest explanation is geography. Alaska is enormous, rugged, and unforgiving. Glaciers hide building-sized crevasses, caves, and blue ice mazes that can swallow metal whole. Weather flips fast. Navigation gets tricky. Many disappearances likely rest in terrain that buries and preserves secrets. So where does that leave Project Alaska? With two realities. One, there are intriguing claims about seismic echoes, classified files, and a black pyramid under remote ground. Two, the best public data points deep in the mantle and away from anything pyramid-shaped near the surface. Both can't be true as stated. If there were a surface-adjacent structure that big, we'd expect multiple converging lines of evidence: independent seismic solutions, gravity anomalies, magnetics, borehole logs, satellite interferometry shifts. Right now, we don't have that convergence. But I get the pull. The unknown is addictive. If you want clarity, chase primary sources. Raw seismograms, UAF releases, peer-reviewed analyses. Ask, where's the data? Can others replicate it? What would we predict, and do we see it? Here's my take. The story survives because it sits at the crossroads of tragedy, terrain, and secrecy. Planes vanish for reasons we understand. Weather, geography, human factors, even when answers are hard to recover. And classified will always spark imagination. So, hidden megastructure or urban legend? Right now, the mantle anomaly is real. The near-surface pyramid isn't. If new, verifiable data appears, I'll be first in line to change my mind. Until then, respect the mountains, respect the science, and keep your curiosity sharp. If you learned something, tap like, and tell me, what evidence would convince you either way? End of story. At least for today. One more thing. Remember the early broadcast claims. Keep asking for sources. Extraordinary claims need extraordinary data.
Why do millions of people remember history that never happened? Why do I remember a monocle on the Monopoly Man? He's never worn one. Here's my wild take. The Mandela effect is the result of a hot server reboot. We live in version 2.0. Okay, claim time. Imagine reality like a massive online world. Billions of players, shared rules, synced clocks, a giant server. Most days the server runs smooth. But sometimes, after a big patch, new tech, new information floods, global moments, there's a hot reboot. Not a full shutdown, just a live reset. Systems keep running. The cache, the quick memory, gets out of sync. Our brains are the client. Culture is the cloud. Some cached memories don't match the updated map. That mismatch feels like a timeline swap. It feels like the Mandela effect. Examples? Let's rapid fire. Berenstain Bears versus Berenstein. Bootleg copies. Misprints. A classmate's handwriting. Luke, I am your father. The internet cached the punchline. Pikachu's black tail tip. How cartoons shade things, how toys once looked. Looney Tunes, not tunes. Fruit Loops versus Fruit Loops. New Zealand in the wrong spot on some school maps. Over and over, the same pattern. A memory that felt official, reinforced by jokes, ads, and old packaging, then overridden by a cleaner, corrected, digitized master file. So what's the twist? The reboot isn't supernatural, it's social. The internet turned culture into a live service. Search engines push the most clickable phrasing. Memes compress nuance into punchy misquotes. Streaming platforms replace older cuts with final edits. AI upscales, autocorrects, rewrites thumbnails. Every update is a hot patch on our collective memory. Most people never notice. Some of us are standing on old cache. We feel the seam. We call it a glitch in the matrix. It's really a glitch in the sink. Here's the kicker. Once a false memory becomes social, it behaves like truth. It spreads faster because it's cleaner, funnier, easier to recall. The monocle makes the Monopoly man look more rich. Luke, I am your father, fits a dramatic reveal. The brain loves stories that snap. The server loves content that clicks. Snap plus click beats facts in the wild. So, do we live in version 2.0? Yeah, in the sense that our shared reality is constantly patched. Your job and mine isn't to pick a timeline. It's to check the cache. Ask, did I see it or did I inherit it? Was it printed or memed? If you can't source it, don't swear by it. If you remember a world that never was, congrats. You just felt the reboot. Welcome to 2.0.
It wouldn't be a bang, it would be a chilling, silent moment of panic. One night, while you slept, the moon would simply be gone, but the disaster wouldn't be in space. It would be here, on Earth. The tides would vanish, crippling ports and marine life. The Earth's rotation would violently change, leading to superstorms and 10-hour days. But that's the science. The real truth is darker. The moon wasn't stabilizing us, it was shielding us. NASA and world governments have always told you the moon is a natural satellite, a simple rock, but the official reason for its disappearance would be a lie. It vanished because IT was removed. The moon is not a rock, it is a construct, a giant hollow artifact placed there to regulate the planet's frequency. Its disappearance means the shield is down. The true reason for the vanishing is that the code has been exposed. With the moon gone, Earth is now defenseless against the cosmic noise. The electromagnetic smog is replaced by raw, untranslated signals, signals that can rewrite your consciousness. The moon was a frequency dampener. Now, without it, the mind under attack is total. Every human being is receiving the code that turns us into machines. They removed the moon to activate the program. If the moon is gone, the fight is over. Unless we can build a new defense, a mental firewall, the only way to survive is to decode the signal before your mind is fully overwritten. The system is exposed. You know the truth about the moon. Subscribe to Cryptos Code, and we will start building the mental firewall. Check out our shorts tomorrow for the first step to securing your mind. I love a good space mystery, especially when it turns into clarity. NASA just confirmed that interstellar visitor Thurii Atlas is a natural comet. No alien techno-signatures. It's a natural comet, not a spacecraft. It looks like a comet. It behaves like a comet. Its chemistry shows no artificial patterns. But here's the twist. It's no ordinary snowball. Scientists see an unusually high ratio of carbon dioxide to water. Gas is rich in nickel relative to iron. Those signatures don't match typical solar system comets. That hints at an origin in a very ancient, very distant star system, maybe carrying material older than the sun itself. Yup, older than us. If from the Milky Way's thick disk, it could be about 7 billion years old. Imagine a fragment drifting for eons from the direction of Sagittarius. NASA spun up an unprecedented solar system-wide observation campaign. Hubble, JWST, Perseverance, Maven, Lucy, Psyche, SOHO. Parker Solar Probe. Since discovery on July 1st, a dozen-plus assets have been tracking and analyzing it, and the behavior? Wild. The comet shows an anti-tail, dust pointing toward the sun. It happens when larger particles launch from the hot day side, and are heavy. Solar radiation only nudges them back slowly, so dust first surges, sunward, then gradually swings back. longer and stranger than usual. You might have seen headlines about activating planetary defenses. Reality: the International Asteroid Warning Network had a 2025 comet exercise planned. 3I Atlas is the perfect test target. Bright, interesting, guaranteed not to hit Earth. Think of it like a global fire drill, practicing procedures while nothing's actually on fire. So to recap, 3I Atlas is a natural comet, not a spacecraft. Extra CO2, nickel-rich gas. It's under the most widespread space observation we've ever done for a comet. It's teaching us how dust, ice, and time behave after billions of years wandering the galaxy. If you're skywatching, check reputable guides for timing and visibility. Never aim optics at the sun, without proper filters. Personally, I'm thrilled. Every interstellar visitor is a message in a bottle from somewhere else. The galaxy is old, diverse, full of surprises, mystery to clarity, delivered. If this blew your mind a little, hit subscribe, and I'll keep chasing the next big space question.
When D-Wave does its calculations, it taps into parallel realities. That's the hook, right? It sounds outrageous, like sci-fi. But it's also how we ask a deeper question. If quantum machines explore many possibilities at once, who designs the possibilities they explore? Who are the architects? Okay, quick reality check. D-Wave's system is a quantum annealer. It engineers qubits to settle into low-energy solutions on a problem landscape. Whether it literally branches into parallel worlds is an interpretation, not proven fact. But as a metaphor, it's powerful. Because the shape of that landscape decides what outcomes are easy, and which are basically invisible. So, who do I call architects? Anyone who shapes that landscape. The person who encodes your problem as a cost function. The one who chooses how qubits connect, which biases to nudge, which couplers to turn up or down. The engineer who decides the schedule, the cooling curve, the tempo of the quantum dance, the noise whisperers, shielding, cryogenics, calibration, so quantum behavior survives long enough to matter. The theorists crafting embedding so real-world mess fits onto tidy quantum graphs. Here's the twist. The parallel realities are not just out there. They're designed in here. Every constraint you add creates a valley. Every penalty moves a mountain. Every bad assumption digs a hole you fall into over and over. Imagine you run logistics for a city. You map deliveries, traffic, fuel costs into a quantum objective. Forget to penalize lateness, and you get a gorgeous route, arriving after the shop closes. You didn't get a wrong answer. You got the best answer to the wrong world. Architects keep us in the right world. They do three things brilliantly. 1. Translate problems into energy landscapes that reflect reality, not wishful thinking. 2. Curate hardware topology. Align qubit connectivity to the problem's bones. 3. Orchestrate schedules and mitigation so the ground state you want is reachable. There's another kind of architect, the bridge builders. Product managers who pick real use cases, ethicists who set guardrails, designers who avoid false certainty, educators who define quantum advantage and its limits. Because hype is also a landscape. Believe quantum equals magic. Celebrate misleading wins. Believe it's a scam. Miss the useful niches. Both paths waste time. Here's my favorite part. The best architects aren't just physicists. They're domain experts who know which costs really bite. Mathematicians who spot symmetry to shrink the search. Software engineers who build hybrid loops. Ops people who measure before they model. So when the annealer calls across possibilities, who answers? Architects. People who shape possibility responsibly. If that's you, or the you want to become, answer the call. I'm going to tell you a story you've already heard. Or at least, that's how it will feel. It's 7:12 p.m. Streetlight buzz. A dog barks twice. You turn the corner, and your brain whispers, "I've been here." Same smell, same angle, same breath in your chest. But you haven't. Not once. That is the déjà vu glitch. the moment the system loads the wrong save file. Now, I'm not saying we're NPCs in a cosmic sandbox, but I am saying your head runs on shortcuts, fast guesses, compressed memory. Think of your brain like a speedrunner. It hates wasting time. It caches textures. It predicts the next frame. Most days, smooth. And then, once in a while, it grabs the wrong cache, and boom. Familiarity hits before the facts arrive. Here's the wild part. Déjà vu doesn't feel like remembering. It feels like re-entering. It's not, oh yeah, last summer. It's I am inside a scene I've already lived. That split second of double exposure, present on top of almost present. There are a few theories. 1. The brain's two cameras desync. Your emotional tag arrives a hair before your detail tag, and the mind interprets that lead as already known. 2. A tiny glitch in attention. You glanced, zoned out, glanced again. 2 near-identical snapshots stitched as a memory loop. 3. Predictive coding. Your brain predicts this moment so well that when the moment arrives, it feels like recalling, not perceiving. But let me give you a way to feel it on purpose. Not a hack, more like a nudge. Change nothing, except your label. When that electric hum hits, the breath, the corner, the shade of the light, don't swat it away. Say, the system loaded a save. Watch what happens. The scene sharpens. Colors step forward. You notice the tiny tear in the poster, the uneven rhythm of your steps, the exact temperature on your skin. The glitch becomes a magnifying glass. Because déjà vu is not just a bug, it's a status message. Your brain saying, my future guesser and my archivist just overlapped. That overlap is where creativity hides. It's where you see patterns you were too busy to name. And yes, there's the spooky thought. If there's a save file, who's saving? Maybe it's you. The version that simulates 10 outcomes while you sip coffee. The version that rehearses a conversation in the shower and lands the line later. That's a save file. Déjà vu is when the rehearsal bleeds into the performance. So next time it hits, don't panic. Stand in it for one breath longer. Let the double exposure resolve. Ask, what did my brain think would happen here? Then choose your next move deliberately. Have you ever stopped to consider a truly radical idea? People often think the Great Pyramids of Giza are simply elaborate tombs for powerful pharaohs. They look at the massive circle of Stonehenge and see it as a calendar, or perhaps a temple for ancient rituals. But what if they were something more? What if these world-famous monuments and thousands of others like them were not just isolated structures? What if they were nodes on a global network? Imagine them as gigantic, silent routers. They were not transmitting data for our phones or computers. Instead, they might have been part of an ancient planetary system of energy. This concept sounds like science fiction at first. It challenges everything we learn in conventional history class. We are taught that ancient civilizations were disconnected, each developing in its own little bubble of the world. But this idea invites us to look at the past with fresh eyes. It asks us to be curious about the connections we might have missed. It doesn't seek to dismiss the hard work of archaeologists and historians. It simply proposes adding another layer to our understanding. It suggests that our ancestors might have known things about the Earth itself that we have long forgotten in our modern technological age. The hook is simple and direct. This is where our journey into this fascinating mystery truly begins. The concept of ley lines is surprisingly straightforward. Imagine you take a large map of a country, like England. Begin plotting ancient megalithic sites, old churches built on pagan foundations, burial mounds, other sacred places. As you add more and more points to the map, a startling pattern begins to emerge. Many significant sites fall along perfectly straight lines. These are not random alignments. They are too precise and too frequent to be mere coincidence. Alfred Watkins first popularized this idea in the 1920s, calling them lays. He thought they were ancient trade routes or trackways, marked by landmarks. But the idea evolved. Some researchers now suggest something more esoteric. They propose ley lines are channels of terrestrial energy, energy that flows across the planet in a vast, intricate web. Ancient builders, attuned to subtle forces, could sense these currents. They placed major monuments where lines crossed, nodes of power. Think of it like a human body's circulatory system. When we look closely at the structures built on these energetic hotspots, we find more intriguing clues. The pyramids are not just randomly shaped piles of rock. They are marvels of geometric precision. Their angles, dimensions, and orientations are incredibly exact. The Great Pyramid, for example, is aligned to true north, with an accuracy that modern builders would find difficult to replicate. Similarly, the stones of Stonehenge are not just arranged in a simple circle. They are positioned to align with the movements of the sun and moon at critical times of the year, such as the solstices. These are not isolated examples. This pattern of precise alignment repeats at ancient sites worldwide. This precision suggests a specific purpose. If you are building a router, you do not just throw the components together. You arrange them in a very specific way to manage and direct signals effectively. What if the geometry of these ancient structures served a similar function? What if the shapes of pyramids, the arrangement of standing stones, the layout of temple complexes were designed to interact with the natural energy of the ley lines? They might have been built to draw in, concentrate, amplify, or even broadcast this terrestrial energy. The materials used, such as granite, which is rich in quartz crystals, could have played a crucial role in this process. The global nature of this grid forces us to ask a difficult question. Who was the architect? If ancient civilizations in Egypt, Britain, Peru, China were all building nodes on the same worldwide network, they must have been working from a common blueprint. Yet mainstream history tells us these cultures had little to no contact with one another. We have found no historical records of an international conference of pyramid builders or a global consortium of megalithic engineers. So where did the plan come from? This is where the theory moves into even more speculative yet fascinating territory. One possibility is that the knowledge was passed down from a much older, lost civilization. This would be a predecessor culture that was global in its reach and possessed a sophisticated understanding of planetary science. This mother culture could have mapped the Earth's energy grid long before the rise of the civilizations we know from our history books. They may have left behind the knowledge, which was then inherited and implemented by later peoples around the world. This would explain the uncanny similarities in architectural styles and astronomical alignments found at ancient sites separated by thousands of miles and thousands of years. Another, perhaps simpler explanation is that the blueprint was not human at all. Perhaps the grid is a natural feature of the planet Earth itself. The lines of energy may be created by underground water flows, fault lines in the Earth's crust, concentrations of magnetic minerals. Our ancestors, living in closer harmony with the natural world, may have simply learned how to detect and utilize this pre-existing network. Restating the core idea, the theory proposes that many of the world's most mysterious ancient monuments were not standalone structures, but functional parts of a planet-wide energetic grid. This grid, formed by ley lines, may have been used for healing, enhancing consciousness, ensuring fertility. Thinking of these sites as ancient routers is a powerful metaphor that helps us grasp the concept of a connected, functional network. This perspective transforms these stone relics from silent tombs into the humming machinery of a lost global technology, a technology that was intricately woven into the fabric of the Earth itself. Why does this idea matter today, on December 30th, 2025, as we stand on the cusp of a new year? It matters because it challenges us to reconsider our place in the world and our relationship with the planet. In our modern era, we are increasingly disconnected from the natural world. We live in artificial environments and communicate through invisible digital waves, often forgetting the ground beneath our feet. This ancient theory reminds us that the Earth is not just a passive ball of rock. It is a dynamic, living system with its own energies and rhythms. It encourages a sense of wonder and respect for the planet. Embracing this line of inquiry does not mean we must abandon science and reason. In fact, it invites us to use our modern tools to investigate these ancient claims. Satellite imagery, ground-penetrating radar, magnetometers to map these lines and measure the energies at these sites. We can approach the mystery with a spirit of open-minded curiosity, balancing wonder with rigorous investigation. Whether the theory is ultimately proven correct or not, the process of exploring it teaches us to look for patterns, question assumptions, and listen to the subtle whispers of the past. The evidence is not yet conclusive, but it is deeply compelling. The countless alignments, the precise construction, and the strange phenomena reported at these sites all point toward a deeper mystery. We are left with a powerful and resonant question that echoes from the ancient world to our own. Were our ancestors simply building tombs, temples? Or did they inherit a profound secret about the Earth itself? A secret that enabled them to build a network that we are only just beginning to rediscover? Well, it's a question that stays with you.
Quantum teleportation. In 3 minutes. Does it really exist? Does teleportation really exist? Short answer, yes. But not the sci-fi kind. I'm talking about quantum teleportation. Moving information, not matter. Myth busting first. No one is zapping your body across the room. No atoms vanish here and pop up there. And it does not break the speed of light. Okay, what is real? Quantum teleportation transfers the exact state of a tiny system, like a qubit, from one place to another. How? Entanglement. A normal message. Step 1. Create 2 entangled particles. Keep B far away. Keep A with the sender. Step 2. The sender performs a special joint measurement on A and the unknown qubit X. This destroys X locally, but imprints its recipe in the measurement result. Step 3. Send that result by ordinary communication, text, fiber, radio. Step 4. The receiver uses that info to adjust B. Boom. B becomes an exact copy of X's state. Nothing material traveled. The state did. No faster than light trickery, because you still need that normal message. Does it work in real life? Yes. Physicists demonstrated it in 1997, across labs, under cities, from ground to satellite. In 2017, China's Mikius satellite teleported states over 1,200 kilometers.